slides and some stuff to discuss. So we're going to go ahead and start. And if someone misses a little bit of the beginning, friendly neighbor. So. Okay, so this is 10 secrets to secure mobile apps. And basically we'll talk a little bit. My name is Jason, and I work at HP Mobile Research and pen testing and iOS stuff. iOS is mostly my area, as well as web hacking, and I come from a pen testing background. So, and my Twitter's up there.
And my name's Daniel Miesler. Also work with HP Fortify on Demand. So we both work for the Research and Development Group. They're at Fortify on Demand. Testing. So wanted to start off by sort of reviewing why I'm talking about mobile. One of the big things to think about is the traffic increase in mobile traffic. We're talking about a 26 massive increase. We're talking about a device per capita very shortly. And we're talking about mobile payments coming close to $1 trillion very soon as well. Just becoming extraordinary. And the more the performance gets better, the more people use it instead of systems. Desktop, common. And what that really means is that you'll be able to, whatever that means, better way to do input with board, and a better way to have a display on your wall or not need to leave your mobile device. So this year is the year that is actually going to exceed web traffic, and I think it might have already happened actually. And what that really means is that mobile will be just computing, right? We'll actually need another word like static or sedentary or on-mobile computing for doing computing without a mobile device. And the reason this is so important, obviously, is because wherever the users are is exactly where hackers are going to go. All the traffic is, all the apps are, and all the activity is. So the other thing about mobile is it's the #1 place right now. When you look at web apps, time ago, have a mobile app out or feel way, way behind. That was the case a year ago. It's definitely the case now. And the people who are building these mobile apps traditionally are not security. They're often just very niche. This is not all developers who do mobile, obviously, but many are very focused on just the mobile piece and aren't familiar with security at all. And it's really assuming, it's really causing a lot of issues. One of the main issues that they assume the back end of the mobile application is not going to be viewed by others, and that causes all sorts of issues we're going to talk about.
Cool, so this is OWASP. This is the OWASP Mobile Top 10. There's actually later on today. This is a project we put together similar to the Web Top 10, where it goes over the 10 most prevalent and risky domains, vulnerabilities. So I won't waste your time going through all of the categories. Today we're only going to touch on a few of them, but this project is very important. It's very near and help with it. So if you do any mobile development, if you've ever written a piece of secure code for any mobile platform, if you have ideas on how to make the project better, if you're good at wiki editing, we could really use your help. It would mean a lot to us. It would mean a lot to really the world. If you look for mobile security code snippets, code examples, if you look for guidance, there's very few resources right now. So we're looking for help. And there's more on that later too. So this presentation is the top 10 ways to secure your mobile apps. And so we have about 7.5 domains in here, top level domains like, store your data securely and transport and stuff like that. But there's more than 10 recommendations. There's a lot more. So, take it as what you will. So the first domain, and it matches verbatim, is data storage. So a lot of the issues that you'll see in mobile apps, especially in the news or any application that gets about a mobile app, or if you're on a mobile app assessment team or you're a developer, first thing that they talk about is storing data securely. This means passwords, credentials, private data like text messages that might get handled by the app. We have a whole screen later on dedicated. We probably should have put it at the beginning of the slide, but the types of risky data that your mobile app can handle. So the first thing is, if at all possible, don't store anything. And that's like a pie in the sky kind of thing, I understand, to developers. But if there's passwords or personal information that's very sensitive, don't store it. Keep it effaceable in memory or something like that. Don't put it in a data storage unit like a SQL database or a plist file or something like that. So there are several secure storage functions on each platform. On iOS, the first thing that you want to do is, if you're using small fragments of data for keys or passwords or cookies or session data, you want to use the keychain. We're not giving code level examples because we have a long list of resources at the end that have examples for all of this stuff. But the first one is a lot of people, what they do is they store passwords or secrets or something else using NSUser. What this does is it stores it in an XML file that's unencrypted on the file system. So anybody who plugs your phone into a computer can grab that XML file and pull these secrets out of that. So avoid at all costs using NSUser defaults on iOS to store secrets, at least. Configuration stuff, maybe. Preferences, maybe, but definitely not passwords, session tokens, encryption keys, stuff like that. For larger data sets, databases using core data or SQLite commands, when you're gonna use those, you have to make sure that when you instantiate a database on iOS, you call the protection API. And the data protection API is a method that will basically apply encryption based on some parameters of the phone. So there's a list of one being no data protection, meaning when the phone is plugged into a computer, you can pull files off of the phone easily. The highest being the file is encrypted unless the application is open. And there's a couple in the middle there. There's one that allows you to basically, whenever the phone is unlocked once, ever in its power on, you can read a file. It's not encrypted. So that's the default one for iOS. So if you instantiate a data with NSManage objects or something like that on iOS, that's the default one that gets applied to the file when it's written to the file system. After the phone gets unlocked once, that file is unencrypted until the phone is rebooted. And that's pretty unsafe for most secure data that's stored in a database file. So what you want to do is make sure that you apply NS file protection complete unless open. That's the API level that you want for all high-level security stuff. For Android, for like keys and passwords, you can use the Android key store. And just like with the iOS keychain, it's very similar, but when you store stuff in the key store or the iOS, make sure it's a crypted value, it's not a plain text value, because when you're dealing with mobile devices that have been jailbroken or rooted or exploited in some way, they can dump the keychain pretty easily. So you want to make sure you have some kind of encryption routine that just stores garbage data that they're not going to understand. And then you want to make sure you're not a shared location or world readable location. So this is the SD card. And we have some slides on what APIs allow data to be stored on the SD card instead of directory. So this is an example here of just core data write. Basically, the file on the phone, we've exported it out to our computer. It's unencrypted, no encryption class on it, and we just strings out the file. And you can see here username and password, and then the password is please don't store me, bro. So that is how simple it is sometimes to just get passwords out of these unencrypted data stores. And this is an iOS example. This is of another way to leak data. This is in another slide that we have called. This is basically a content provider in an iOS app or an Apple from any application. So this was a browser. I think this has been patched already. It might not have actually. A browser that basically allows any other app on there's browsing history, which can include session tokens in the URL. It can include posted to the device, pretended we're another app, and pulled out the history of this browser. So what this did is it basically all the IPC files content providers have a permission flag in the Android file. So make sure that's what makes this possible. So pointed resources for handling data. So there's the iOS data protection classes document, and these slides will be up with code snippets on each data protection class that you can apply to SQLite or anything system. There's also a guide on encrypted data using core data. And then there's a third-party project or library, extra encryption on the iOS platform and the Android platform, basically for SQLite. And then for Android pointed code example, you search, and this project actually is super cool. If you go there, this is what it looks like. They basically wrote in a whole guide with links to good code snippets and bad code snippets. And so this is probably one of the standards right now for this type of thing, at least that's publicly available for Android applications. So we highly recommend this. And you can see the first one is store data or information on the SD card, which we talked about. They also have one about content providers, which we showed a screenshot of. So this will give you pointed advice on how to fix these problems.
Can you switch so you can see the thing here? Like a larger version?
Maybe. Is this you or me?
That's me.
Okay, good.
All right, so now we're going to talk about server-side, which I mentioned earlier. So a big problem with mobile apps is basically people not taking the server-side seriously. Focusing on the mobile app itself, realizing it's connecting to a back end, and oftentimes the data that's stored in that back end, that data out, a problem if it's not protected correctly. So definitely the most overlooked part of mobile application. Probably over half of the vulnerabilities we find in our practice are server-side, and even more than that, percentage-wise of the critical are server-side. So all input standard for any application really, but web application. And use whitelisting when you can, right? You know, don't accept things you don't have to. There are a number of open source WAFs and other types of protection that you can use to protect the server side. So definitely you want to look into those. OWASP, a couple of options, but look at what's available for your platform and try and use them if possible. You want to have for APIs, this one, a lot of mobile apps are API based, and oftentimes there's no authentication. A sort of separate problem, there's not much access control either, so you can just sort of connect directly and pull tons of data out of the back end in a lot of cases. You want to make communicating all to your APIs. You also want to have updates on your software, right? You want to make sure the back end is completely updated, and that includes parsing, right? Make sure your parsers are up to date because that's a really big angle of attack. You want to make sure your content type is set correctly so that you can't be tricked with malicious to setting the content type correctly to JSON or whatever is really help a lot. Where you can, instead of get, it's just good policy in general, but definitely want to do that. The other thing is cache the content, right? Because when you cache content, now it's being stored, going back to what Jason was talking about, on the device. It'll actually come down the device and stay there, so actually be pulled off later. So try not to cache it if possible. This is an example of a password that you see was being in the get. You don't want to see this. Also want to mention this project that Jim is actually leading. Interesting take on an OWASP project. The OWASP top 10, as you know, are things to avoid, right? Whether they're risks or threats or vulnerabilities to avoid. This project takes the opposite approach and says, what should you be doing, right? You should parameterize your queries. You should validate all input instead of what not to do. Really interesting project. We recommend you take a look at it.
Okay, so the next section is encrypting and protecting traffic. So where possible, you always want to use HTTPS over HTTP, and I know this is a performance concern for some of you. It's really what you need to do. Mixed mode content on APIs exposes the user mobile device because they might be connected to a network that's not their own or not trusted is really important. So just disable all your HTTP endpoints if you can. Setting your cookies in HTTP only, saves a lot of headaches and passwords and man-in-the-middle attacks and stuff like that. This is general web stuff as well. Use the proper cipher strength and algorithms for SSL. There was a lot of talk about the types of attacks that can exist in SSL algorithms yesterday by the white hat guys. It was pretty cool. And then whenever possible, when you're using certificates, you have to use them well, and then also, if you can, use certificate pinning. So, but if you do it with a mobile app, well, it's more common on mobile apps, and it also really messes up an attacker. So, anyone who's ever tested a mobile app, if you've embedded certificate pinning, it can tell you it adds a significant amount of time to disable the certificate pinning, or if it's at all possible. Of different platforms, certificate pinning code at that link right there. It's by a really cool consultancy called ISEC Partners. And so they have some plug and play code where you can enable certificate pinning. You just bundle your certificate, force the user to connect with that certificate, and if the server gets a request without it, it will just kill it. So we're going to talk about making the bad guy's job harder. That's actually one of our domains, so that'll have more of that in it. So things that are like implementations are trusting any certificate or self-signed certificates or any root of a certificate, allowing expired certificates. These kind of things allow trivial man-in-the-middle attacks or spoofing since you might be on an adversarial network. Mixed mode is bad, like I said. Don't keep APIs open. You can use an attack like SSL strip to downgrade a connection to HTTP if you still have the HTTP endpoint open, forcing the user to expose their cookies or their wire. And then there's a ton of other SSL checks. If you didn't see this link, it came out last week. It's the SSL checklist for penetration testers, but also very useful for developers. It's like the 40 top misconfigurations with SSL certificates and algorithms that you can find. And basically it tells you how to do them manually. So there's a lot of tools that'll do SSL checking for you, like SSLIs, or there's like a Qualys site that does some SSL checking, but they don't all do the same things. And so this has a pointed list on how to actually use OpenSSL on the command line to check for these issues. And these slides are available, so you'll be able to find the link and click it, and then it'll take you to this thing. So, but you could also just Google SSL checklist for penetration testers, or it's on Daniel and I's Twitter as well. So here's just an example of this is doubly bad. This is a password sent over GET to an API, and a JSON-based API, and it's also over HTTP. So don't do this. This is bad. This actually happens in the real world. People do it all the time. And you can see it's sent from an iDevice because you can see CF network is the call and the user agent down there. Just an example. This me? This you. Okay. So the next one is know the operating system you're coding for. So this kind of maps to the OWASP top 10 unintended data leakage category, but it also maps a little bit to insecure data storage. So, take it as you will. Problems are sometimes similar in those two categories. But take a look at your OS and realize the functions that you might not, well, I guess it's hard to realize what you might not know, but use this list to kind of guide you in what what the OS does that might make your application insecure, even without you knowing it. So on the iOS on the left side, iOS has logging calls. So when you log, these logs are available to all of the apps on the system, as well as plugs the phone into a computer. A lot of people don't realize this. So let's say that you have an application like Facebook, and you've embedded it to do debugging or something like that. And you don't remove it before production, and it ships. All of the data on the phone, all the data on the phone can just pull a copy of the logs, and if you've logged sensitive data, it's now theirs. So that's important to remove NS log calls of sensitive data in production. Shots to background applications. So when you press the home button, what happens is that the OS takes a screenshot of whatever screen you're on. The screen you're on had sensitive data, or something like that. Then that application screenshot is now considered sensitive data, and it gets stored on the file system with the lowest data protection called on that image. So people can plug the phone in and pull it off as well. URL caching. This is one where if you don't have the cache header set correctly, like we talked about on the web side, all requests that you send to the web server and response data, as of iOS 7, I think it still does response data, will get cached in a database file with the lowest protection API as well. So this is the cache.db file, and we'll show an example of this in a couple seconds. Whenever you use the keyboard on an iOS application, in order to provide you with the autocorrect function of what you might have spelled wrong, it creates a text file with the characters that you've entered. So kind of like a little built-in keylogger as well. Copy and paste, whenever you copy words, they go into a buffer that's easily pulled off from the phone. And then photo sharing is one that we'll show in a couple seconds. Whenever you take a photo with your camera, you have two options of storing it. One is storing it in the application sandbox directory. One is storing it in the global photo roll. The global photo roll is accessible to every other app on the phone. So on Android, you have the same thing, URL caching. This happens with the browser API on Android, but same deal with iOS. So make sure you set the cache headers right on your website or API. Logging in Android is logd. Same issues. The logs are accessible to anybody. Content providers, when you set up a content provider, like we showed earlier, you have to make sure that it's not world readable and world writable. Storage outside of the application sandbox directory, like external storage on the SD card, was already mentioned, but mode world read and write, these are bad things to have, and these will be set in your Android manifest file. Web views, so any data stored by a web view using HTML, examples that have some code that was used in third-party frameworks. So if you're using a third-party framework like PhoneGap or something like that, basically they're handling a lot of this stuff with HTML5, and they'll do HTML5 data storage, and you have to ensure that there's some encryption or that data that's encrypted. And then inter-process communications like services and broadcast receivers, you have to make sure that they have permissions set on them. And then data or sensitive data stored in the application heap in memory, because if you have a rooted phone, you can pull data out of memory pretty easily. So this is an example of logging for an iOS application. So this was a banking application we did. For debug, they were basically all transactions. They were taking the account, the card number, the description, maybe the check number, any information. All this was going to the global system log. Application on the phone could pull this data out. So this is basically an NS log call that they left in production. This one is an example of the iOS photo roll thing I was talking about. So basically, a lot of banking applications will do this now, where you take a picture of your check and it'll deposit it for you. A lot of them store it to the global photo roll, which will put that picture of your check along with all your other images, and any other app that you've installed on the phone, what you've said it can access your images, can now take this check image out of your phone. So when you're storing check images or any sensitive images at all, they should be stored not using the global photo roll, but using the application sandbox. Just drop them as images into the sandbox. This is an example of the caching we talked about. So if your site doesn't have control enabled, it ends up in this file called cache.db at the top inside of your application directory. And here you can see there's a whole bunch of data about this. What was this? This was a credit card application and transactions and inquiry details and stuff like this. So this ends up on the file system with either the weakest data protection class or no data protection on iOS. Cool.
All right, so we're going to talk a bit about knowing into your application. So thing to know about is when data can be pulled off your application or off your mobile device, it's usually dependent, and increasingly so, it's becoming more and more dependent on how much permission you've given various applications on your phone, right? So there's lots of different data you're worried about. You're worried about name, address, your geolocation, email, phone numbers, contacts, application data, sensitive data that you might have entered, credentials you could have entered for various different networks. Based on what you've done on the right here, where it's asked when you first installed, hey, can I do this? Hey, when you say things, keep in mind that you're opening yourself up more and more to data extraction. So one thing to consider when you're looking at your mobile applications, either whether you're mobile applications or you're building them, is to use proxies actually between your app and and maybe multiple back talk about. So is one, Burp another one.
Zap.
Yeah, Zap is. There are a number of options out there, but you just want to what's going on. So here's an example. Some content actually being sent out. This was actually a yeah, it was linked, and basically the regular content was between the mobile app and the back end. In addition to that, which was sent to your app because the other functionality you didn't know you were adding. So sort of an example in our practice multiple times that happened. In the women's health application, it was a mobile application. It was meant to take in some pretty sensitive, could be sensitive data. The data was going into the app and it was protected between the mobile app and the back end. Works take tons of traffic so they don't. So what data entries, you know, people were putting very sensitive data into it, and a copy of it was going to the analytics network with no encryption. And if you only audited just the main area, you wouldn't cover that. So I'm going to talk about using traffic, network traffic for your mobile apps. So going back to the previous point, developers often assume that their apps are going to be well behaved. They're going to assume that you have your basic client and you have the main backend that it's talking to, and that's probably it, right? Not always the case. You would like to think that, but you're doing that. So one thing you can do that we do in our practice is capture all of the data during a session. Capture a full session of you exercising the app completely, and single PCAP. And what you can do is actually use TCP dump and T-Shark, and you can actually break this giant PCAP individual hosts that were communicated with. And what's really interesting is when you show somebody, a developer, you know, who do you think this mobile app is speaking with? And they say, well, here's the IP address of the back end. You show them the output of this, different hosts, and they say, well, that's not coded in. How did that happen? And then you have to show all these other avenues that the mobile is actually speaking through. So once you have this master PCAP, what you can do is you can actually use TCP dump to break PCAP in PCAPs. Now you have multiple PCAPs, which lets you do some pretty entered sensitive data into the app, right? The data that was entered was credentials. You also entered other sensitive data that was app related, so maybe health information or financial information. Well, what you can do is you can have the clear text of that, but you can also transform it into multiple different types of encoding and then search for all those iterations inside of these individual PCAP files. So if you get a hit on one of them, it's automatically really interesting information. You can also do that same searching on the file system as well for device security. So what's really interesting is now that you know you're talking to all these various hosts, what are the reputation of these hosts? Are they completely unknown to the overall information security community? Does DShield know about them? Are they listed as unknown? Are they listed as benign? Are they listed as malicious? This is really helpful for Android apps, in particular malicious apps, most of which are Android, but not all, where you can actually run the app and actually see the scattering of the multiple connections, and then look at the endpoint reputation and see that a lot of them are actually malicious just off the bat. So you can find your data moving across those various connections, and if you find it going to a malicious one, you automatically have a critical, right? If you see your data going across any of these in any form, it's automatically a finding. And the reason for that, of course, is that encryption was not used, because we're using grep, right? If this was a TCP session that was encrypted, grep would not work. So getting hits from this technique is really a valuable way to learn about your application.
So the last broad level domain we have is make it hard for the attacker. And this was an addition to the OWASP Mobile Top 10 called binary protective. Hoopla about it this year about whether it should have been added or not. But we think it's really valuable because the more time the attacker wastes on getting data app, the less likely they are to continue doing it. Also, the skill level for mobile hackers goes from like super script kiddie and like never done anything before. It's like there's like nothing in between, and then there's your super elite mobile hackers who are doing like jailbreaks and stuff like that. So, so adding these protections takes care of, you know, maybe like 60% of the population that just wants to crack your app to distribute it on a rogue store or, you know, wants to put you in bad encryption. Once you break one of the tools, away. So on the left side, we have iOS, right? So iOS comes with 3 compiler protection flags that not a lot of basically in the form of memory randomization optimization. There's stack smashing protection, which is memory protection. And then there's using the automatic reference counting memory system for iOS. Those are 3 basically checkboxes and objectives in Xcode that you can just check, and we'll show screenshots of them, and we have links on how to enable them, that out of the exploit type attacks that might come against your mobile attack in userland. Then there's jailbreak protection. So jailbreak detection is putting some code in that will basically query the file system or other places to see if the application is running on a jailbroken device. And you don't want your application running on a jailbroken device because the attacker has all on a jailbroken device. They can hook into your application, make it do things that you don't want it to do. They can query all the sensitive information. Once they have control of the device, then game over. You can bake in routines, basically functions that look for certain paths that are installed with jailbreak code, and then kill the app if it finds it. There's some other tools too to basically obfuscate your code or add routines to do integrity hashing or stuff like that that are free. So one is obfuscator. This is a whole discipline itself that'll obfuscate Objective-C. This, I don't know how this is going to work when Swift comes out, so we'll have to see. IMOS is a project that was demoed yesterday. It was a talk called iOS Integrity, I think. It's a whole project with separate code snippets and routines to do integrity hashing, jailbreak protection. There's one that you can drop in to add a custom pin to your application to encrypt it twice in addition to your device pin. They have like security controls, and I think they dropped some more yesterday. And it's part of the OWASP mobile project, which we're part of. So IMOS is definitely something to look at if you want protections on iOS. Stripping usernames and paths from your application before it goes to production. This is really important, as well as symbols. And then there's another called the Reverse Engineering Code Modification Prevention Project, which gives more information and code snippets about basically defeating an attacker and who's trying to reverse engineer your project, which includes anti-debugging, anti-reverse engineering. So someone tries to hook up your app to a reverse engineering tool like IDA or Hopper or something, trying to debug it with GDB, it will kill those tools immediately or cause them to give output that's just nonsensical. So adding these types of protections to the apps really destroys an attacker. If you added all of these on the left side to an iOS app that we were going to assess, it would maybe to even test your app. I mean, that's pretty accurate, right, Greg? Greg leads our mobile team, so yeah, it's really a pain in the butt, right? Yeah. So the memory stuff is pretty much taken care of on Android. You don't have to worry about any of the userland kind of extra stuff. It just happens automatically when you compile, so that's fine. Code obfuscation, ProGuard is the free tool to use for Android applications for obfuscation. DexGuard is the paid version of that, which has some extra functions. You also want to look at integrity hashing checks. Facebook has an extra layer of SQLite encryption in a project they called Conceal that they released last year, I think. I haven't used this before, but and it also does some SQLite database optimization, so I would check it out. And then root detection is the same as jailbreak detection. You want to make sure you're not running on a rooted device, and there's code snippets for that in the CERT project that we mentioned earlier. So this is an example of a compiler protection for so this is a position-independent executable. There's a link for the whole walkthrough on how to do this, but basically we've taken an app and we don't even have to decrypt it to check to see if this exploit mitigation is there. But you basically run a tool on it to see if it's enabled, and if it's not, then that's an issue. This is the same deal with stack smashing protection. Here you can see in Objective-C how you enable it. You go under other C flags and enable FS Stack Protector All. And these are just things in Xcode, right? They're menus that I don't know why they're not enabled by default. They might be on the next version of Xcode. You never know that as default. But, so that's making it hard for the attacker.
Yeah, so just a few takeaways. Mobile increasingly is becoming computing, right? Don't store your data if you don't have to. Use the APIs that are available to protect your data on the device. Know what you're adding to your app, because the functionality that gets added could actually harm you. Make sure you're looking at your network traffic. Look at it objectively, see what's really happening instead of what you hope is happening. Look for your sensitive data in that traffic and on the device itself after you run the application. You want to harden your binary, as Jason just talked about, and don't forget the server side. The server side really matters. It's part of the mobile application. It's an important part. So Jason's the for the mobile, and I'm one of the leaders as well. And we just released the 2014 list, but we're already gathering data for the 2015 list. And it's really important that we get lots of feedback from who do testing, from developers, from anyone who can supply data. Because the more data, the better the prioritization of the list is going to be. We'd appreciate your help if you could reach out and provide some data around mobile. iOS 8 came just, I think, 2 days ago. Want to just do a quick little blurb on it. Short answer is that Apple is opening up a little bit. Is this third-party extensibility component. So cross-app communication is now becoming much more easy. We're seeing third-party keyboards. We're seeing sharing interfaces. You can now share out to third-party components where previously you couldn't do that. Notification widget now could be third-party integrated. Touch ID, apps like Amazon now have access to Touch ID where they didn't before. CloudKit always on VPN, some of the security features.
So along with iOS 8, a lot of people ask about Swift, because a lot of the APIs were Objective-C based for iOS, right? So they're saying, is all this going to change with Swift? Is there any difference? So at the low level, the answer is not a lot changes. The insecure data storage calls are still the same. A lot of these certificate calls are the same. The only thing that Swift changes for a developer is syntax, but at the low level, the issues still exist. Some independent studies already on kind of how this works, and some play with that are completely written in Swift that have security vulnerabilities, which are the same ones we showed in the slides, and they're part of the OWASP mobile project as a whole. If you look there, there's a whole bunch of vulnerable apps to teach you how to audit these things with insecurity of source code. So don't expect to see change anytime soon. So then there's also Android Art. So a lot of people who are doing mobile reversing or attacking mobile applications are really worried about Art because it's going to take away Dalvik. And we're kind of still looking about how this is going to affect the mobile landscape, because right now all of the devices as your runtime they still have the ability to use Dalvik. So the applications themselves can still be decompiled and tampered with. And all the API calls are the same, obviously, because it's still Java. But we're still kind of looking into this. We'll probably do a talk on Art pretty soon and how it affects reverse engineering, modification, and protections and stuff like that. So you should look out for that kind of stuff. So we have a whole bunch of projects under we have the top 10, which we've talked about. cheat sheet, which is a testing face document, and then we have the iOS developer cheat sheet, which is a developer-faced security document. And at some level, they're all sort of incomplete. I mean, we do our best, but we have day jobs, and if you feel like some of the information we presented wasn't fully baked, or you go to the site and you want to know more about certain things and maybe you have some expertise, use your help with any of these, as well as anything under the mobile security banner at OWASP. It's, he said in the keynote that we're like 5 years behind in America. Well, you can think of mobile apps as like 10 years behind in security in general, because there's just a ton of stuff that people don't know about the platforms. People, like Daniel said, people who are coding the applications don't have any security training, stuff like that. You'll also notice that these 3 links cover, or mostly this talk was a lot of iOS, a little bit of Android, no Windows, no BlackBerry. That doesn't mean there's no vulnerabilities on these platforms. They all have different security functions, they all have different encryption functions, they're all kind of designed around the same principles, and when you're looking at any source code or you're auditing any type of application, you're looking for the same things. It's just we haven't had the manpower to create those projects yet. So if you do any testing or you do anything like that, we could use your help for those platforms. So we're running out of time. So this slide has links. This is what I'd say you paid the most attention to, other than the high-level topics we talked about. These are all the projects that deal with real snippets of code that you can bake into your application: the security testing cheat sheet, the developer cheat sheet, IMOS, the proactive controls, reverse engineering, SQL Cipher. All the binary protection stuff are listed in blog posts that we've written about. I have to blow through this. Secure coding practice for iOS development, and then the X is a project that you can bake into Objective, or into the IDE for Xcode. You can bake it into Xcode, and it's scanner for Xcode. We also have a GitHub for mobile tools. We haven't put anything on there up there, but we're going to put some of the tools that we use in our assessment team and our source code team up on GitHub. So check that in the next couple days. Again, we work at Fortify on Demand. We do this kind of stuff all the time. We're really looking to keep engaged with the community. If you guys need help or anything, just contact. These are some people who helped with information in this presentation. They're awesome. We work with all of them. We really have the best team I've ever worked with in my whole life. So thanks to them for helping. And then this is us, and we can take any questions now. So thank you.
Hello. Okay, so thank you for coming to my talk. My name is Insuk, and I am a graduate student at MIT. I'll tell you about some of the doing on web security, and in particular trying to make threat modeling more fun and less effort for developers. So before I go on, I'm just going to give you a little introduction about myself. I'm a member of the software design group at MIT, which is led by Jackson in computer science. We do research on a number of different topics ranging from software architecture, requirements, security, safety, all the way down to testing. And we have applied our techniques to a number of different systems ranging from electronic voting systems, medical devices, biometric systems, and of course web applications. Okay, so the first thing we should talk about is what is threat modeling? Now, in the past, there has been some debate about the exact definition or meaning of the term threat modeling. And still today, depending on who you talk to, you're going to get different kind of answers. And personally, the way I like to think about it is basically threat modeling is just an act of asking the question, what could possibly go wrong with my system, with the product that I'm going to build? Okay? Now, let's try to make this more precise. Okay? So, as a developer, when you're thinking about security, you're often working with 3 different kinds of artifacts. Now, you might not write all this down explicitly in a document, but you're going to have them in your head at least. So first thing you need is you need some kind of security requirement. So requirement is basically what your customers want, right? It's something that your customers expect your system to satisfy. For example, if you're building a healthcare app, then your customers are going to expect your system to keep their medical records private. Okay? The second thing you need is you need some kind of description of your system. If you want to reason about the security of your system, then you need to know what the system looks like. And I want to emphasize that the system is not just the code that you write, but it also includes many other things. For example, it includes the hardware component that your software is deployed on. It includes any kind of third-party libraries that you use. So you have to consider all those things to be part of your system. And the last thing you need is you need some kind of description of the environment in which the system is deployed on, right? And the distinction between the system and the environment is that the system is something you create, you build yourself, whereas the environment, you don't really have control over the actions of the agents in the environment. And depending on, depending on the kind of environment that you're working in, you're going to have to worry about different kinds of issues. For example, if you are building an app that's going to be deployed on a desktop, that's very different from the same app being deployed on a mobile device. You're going to have to worry about different kinds of security issues there. So, given these 3 things, then we can go back and restate our definition of threat modeling, which is basically asking the question, or trying to answer the question, what are the possible ways in which the system operating under a particular environment could or may fail to satisfy its requirements? Okay? Now, one thing you might be asking is, okay, well, why do you want to bother with building threat models? Why do you want to build threat models in the first place? Right? Why not just build the implementation, do a lot of testing, apply a bunch of static analysis tools, and find as many bugs as you can, right? And then release the product once you're satisfied with it. And after all, models are never going to be perfect descriptions of your system, right? They're always going to be details in the final product that you're going to miss in the models. So what's the point of doing this? Well, I think the best and most compelling reason for building threat models is that by doing this early in the development, you can discover issues that become really hard to fix later in the development. A classic example of this is getting your requirements right? So if you misunderstand the customer's requirement, and if you build a product that protects a wrong asset, then it doesn't matter how good, how bug-free the product is, right? You're never going to be able to satisfy your customers. And this is the kind of thing that's just really hard to fix once you have an implementation, right? That's something you can just fix with a simple, bug fix. Now, the second benefit of doing threat modeling is that it allows you to explore different decisions you make while you're designing your system. And it helps you think about the impact of those decisions on the security of your product. So one example of this is if you're building a web app and you're trying to decide how you want to manage your sessions for your users. So one thing you can do is you can use client-based cookies as a way of managing sessions. Or you can also implement some kind of server-based sessions, right? And depending on the decisions you make there, right, you're gonna run into different kinds of issues that you have to worry about, right? And doing threat modeling really helps you think about these kind of things early in the development, and think about the trade-offs between different decisions you're gonna make. And lastly, sort of relating back to the first point, is that if you discover these issues early, then you can actually build in mitigations against the attacks into the design instead of relying on patches, which tend to be expensive and not as effective. On the other hand, I should mention that threat models is not intended for a lot of things. First of all, it's not intended to help you find bugs in your implementation, right? There are other tools that can do this. And second, threat models by themselves don't really give you any kind of guarantees about your product, right? It's up to you as a developer to take the knowledge that you gain from threat models and act on it to make your system more secure. Okay, so how do people do threat models these days? How do people build threat models these days? I believe still the most popular way of is by drawing diagrams on a whiteboard. Okay? And in fact, I think whiteboard is probably still the most popular way of building any kind of models in software development. It could be architectural model, design model, or data model. It's still really the most popular way. And I think the reason is because, first of all, it's easy. It's not expensive, right? You just need to get a whiteboard. It doesn't require a lot of training. And also, it's great for discussions, right? Once you have a diagram written on the whiteboard, then it's very easy to discuss it with your colleagues. But it does have its shortcomings. And it doesn't provide support for a lot of things that make threat modeling hard. So what makes threat modeling hard? The first thing that makes threat modeling hard is just the sheer diversity of threats that are out there that you have to worry about, right? So if you're building a web app, you're going to have to worry about things like some guy in Russia setting up a server and trying to apply phishing attacks on your users, all the way down to a bad guy trying to eavesdrop on your wireless network. And now, often the times, the attacker is not just going to use a single exploit in order to break into your system, but to make the matter worse, they're going to try to sort of combine different kinds of vulnerabilities, combine into a chain, and it's going to use the chain to basically compromise one of the requirements of your system. So thinking about these kind of things is just really hard. It's a lot of work. And I think the second thing makes threat modeling hard is that when you're building a system, initially, you don't really know much itself, right? You're still trying to make decisions about how your system is going to look like, what it's going to do. And at that point, you just don't know much about the system yourself, right? Even though you're trying to build it. So what this means is that you're not going to be able to predict different kinds of threats that may arise down the road. So what this means is that you can't think of threat modeling as just one-time thing you do, right? So you can't expect to build a complete threat model at the beginning and then, analyze it and be done with it, right? You're going to have to sort of do this over time, incremental fashion. You're going to have to start with a small model and, add more details as you learn more about your system. So which brings up my next point is that if you draw models on the whiteboard, oftentimes, once you're done with it, you're going to throw it away. But what you want to do instead is you want to maintain, you want to be able to evolve them over time. And maybe you want to reuse them later in a different context or for the next iteration of your product, right? So you want some kind of support for being able to maintain these models and, evolve these models. And lastly, it's just a lot of work, manually trying to enumerate all the possible threats and trying to think of, all the possible scenarios in which the attacker might, try to compromise your system, right? It's error-prone and it's tedious to do. So at this point, I'm going to introduce a tool named Poral. It's a tool that we designed to address some of the issues that I just discussed on the previous slide. So it's an interactive tool, and it supports incremental modeling, meaning that you can start with a very small model, and you can evolve the model, or you can add details to it, you can analyze it, and you can repeat this process as many times as you want. It supports reuse of models, meaning that if you capture a piece of domain knowledge in a model, you can actually reuse it. You can instantiate it in a different context or later on if you're trying to build different kind of systems where the knowledge might be useful. And it has a built-in library of threats that can be extended. Let's say if you hear about new kinds of threats that are popping up. And lastly, it supports automated analysis. So it will automatically enumerate the threats for you, and then it will also automatically generate attacks for you, potential attack scenarios in your system. And the way the analysis works is exhaustive, meaning that it's going to explore all the possible scenarios in your system, and that enables it to find corner cases that are quite easy to miss if you're trying to do this manually or trying to do this by writing test cases. Okay? So at this point, what I'm going to do is I'm going to give you a very small demo of Poral. So what I'm going to do is I'm going to use Poral to build a model of a very small, tiny online store that provides 4 basic functionalities. It provides services for creating an account, service for logging in, service for placing an order, and then lastly, one for listing the set of orders you have made. Okay? And what I'm going to do is I'm going to show you how Poral can be used to, in an interactive fashion, to basically discover potential attacks on the system. Okay? So at this point, I'm going to switch to the tool. Okay? So this is the web interface for Poral. And on the right-hand side of the screen is the model of the online store written in the input language of Poral. So I'm going to make this bigger so that it's easier to see. Can you see from the back? Okay, great. Okay, so basically, so in a model of a system, you need to define 3 different kinds of things. The first thing you need to do is you need to introduce a set of data types that you're going to use in your system, right? So for example, here I'm going to introduce a data type called user ID, which basically represents the IDs of the users that's going to use the store, right? I'm going to introduce a set of order IDs, which represents different kinds of orders that the user might want to make. Okay? And I'm also going to introduce session IDs. This is what you expect it to be. It's basically the IDs of the sessions that's going to be used to identify users. And then lastly, the that the user is going to use logging into the website. Okay? Now, here I declare the session ID and the password to be secret. And what this means is that it's simply the attacker will not be able to guess. I'm making an assumption here that the attacker will not be able to guess the session IDs and within the order ID. Basically, you can make an assumption that the attacker will not be able to guess them, right? In fact, in many of the attacks that the attacker has sort of exploited, the fact that these things are very easy to guess. Things like user IDs are just not hard to guess at all. So the set of components. So a system is basically a bunch of components that are interacting with each other, right? So the first, in this case, the system has 2 components. It has a component named MyStore, which is basically the server that's going to provide these services. And then it has a component named Customer, which is the user of those services. Each component has a number of data fields. So these are basically just database tables that store any information that's used. In this case, for example, it stores a database table of passwords that map its user ID to some password. It stores the sessions for the users, as well as the set of orders that the user has made. Okay. Now, so next thing I'm going to do is I'm going to basically instantiate MyStore as a type of HTTP server. Okay, so this is a very important step. So what this does is it tells Poral to treat MyStore as a kind of HTTP server. And the effect of this is that any kind of tags that are relevant or applicable to HTTP server are also going to be used to find attacks against MyStore. Okay? Okay, so next thing we need to do is we need to define a set of operations that the component provides, right? This is basically the API for the component. So for example, the MyStore component has an operation called signup. So this signup operation takes 2 parameters. It takes user ID as well as the password. And it's just going to basically insert that tuple from user ID to password into the password database. Okay? And it also has an operation called login. Okay? So what login does is, again, it takes user ID and password, right? And then it returns a session ID. Okay? So this red here is it's a keyword in Poral that representing the return value of an operation. I should mention is that is this ensures clause. An ensures clause is basically a condition that the operation will have to satisfy in order for it to be successful. Meaning, basically, it describes, you can think of it as basically access control on the input parameters as well as the output of the operation. So, for example, here, the first part of the constraint, ensures constraint for login operation says that basically the password that's stored in the database better match whatever password the user pass in as a part of the arguments for login. Okay? Meaning, basically, the user has to provide the correct password. Okay? And return value from this login function is basically the sessions that corresponds to the user. Okay? Okay, and we also got our operation named placeholder, which basically inserts, it takes user ID and order ID, and inserts that tuple into the database table for orders. And then finally, we got an operation called list order, which takes user ID and returns the order ID that correspond to the user. Okay? Basically, the set of orders that the user have made. Okay. So I'm going to move on to the next component. Right? So the component customer is basically, it represents our user, right? It's a user that's going to use my store. So each customer has an ID and a password, right? So you can basically think of it as a user that has, his or her own ID and password. And I'm going to declare customer type of browser. So what this means, again, is that the Poral is going to treat customer as being a kind of browser. And that are relevant to a browser are going to be used against customer when it performs security analysis. And the final piece of the puzzle is the requirement. It's the security requirement that you care about. So in this case, the requirement that we care about here is that you want to make sure that the orders of the customers are kept private, meaning that only the customer and the my store can modify or access the orders that the customer has made. Okay? Yes?
What does keyword trust mean?
Right, so it means that basically, so this is going to be part of the used in analyzing requirements, basically meaning that when I say confidential and when I pass some data, it means that data can only be accessed or modified by trusted components. So,
but I doubt if the browser can be created as trusted component on the system.
I'm sorry?
I doubt if browser can be treated as trusted component.
Right, so that's a good point. Actually, I'm going to show you that. So in this case, I'm going to assume that the customer's browser is trusted, right? So whenever the customer is using the browser, it's not going to try to compromise the requirement. But you'll see soon that there's going to be an example where there's different browser that's malicious that's going to try to exploit flaw in the system and try to basically violate the requirement. So that's a good point. Okay, so what I'm going to do now is I'm not going to worry about the requirement yet. I'm just going to tell Poral to generate just some random scenario, right? So I'm not really trying to check the requirement itself. I'm just trying to tell, I'm just asking Poral to, okay, just give me some scenarios in the system. Okay. So when I do that, whoops, something bad happened. Okay. Sorry, I have to rerun the analysis. Okay, so when I ask Poral to generate a scenario, it's going to basically try to find just a random scenario that is possible in the system, and it's going to display in a graphical representation. So in this case. So the diagram here shows, but the boxes in the diagram are the components. So the my store is a component. And the circles that are attached to the components are basically the operations, the API operations of those components, right? So for example, my store has an operation called place, right? And that's going to be called by the customer, right? So the edge here between the customer and place order represents the fact that the customer is going to make a call. Okay? And the bottom part of the screen shows the initial configuration of the database that are stored on these components. And one thing I should mention here is that a scenario is basically a sequence of steps where in each step basically some operation happens, right? So each step, there's going to be a call that's being made from one component to the other component. And you can actually step through different steps of the scenario. For example, in the first step, the customer makes a call to place order, and it's going to pass in 2 arguments, right? It's going to pass in the user ID as well as the order ID. Now, another thing I should explain here is that, so I have this thing called user ID 0, which just represents some concrete value of type user ID, okay? So the actual content of these data elements are not relevant here for us. But what we care about is just the fact that basically there is some data element called user ID 0, which happens to be a type of user ID, okay? Okay, so what I'm going to do next is I'm going to actually try to check the requirement, the security requirement here. Sorry, it keeps going back to. Okay, so I'm going to, when I click the Analyze button at the bottom, it's kind of to see. I'm telling Poral to basically try to find me a scenario, an attack scenario in which the requirement of the system could be violated. Okay? So the first thing it finds is it finds a scenario with a single store and some evil client. Okay? Now, you might be wondering, where did the evil client come from? And it came from the fact that my store was declared as a type of HTTP server. And that's going to bring in the knowledge that Poral has about potential agents, bad agents in the environment that's going to interact with any kind of HTTP server. Okay? And also, this diagram doesn't show the customer component because the actions of the customer is not relevant for this particular attack. Okay? So, actually, can anyone make a guess what this? Any rough guess? Sorry? No. Well, so basically, so it involves evil client making a call to this order, okay, and returning order ID, which is the order ID that we want to protect. So if you look at the initial configuration of the MyStore database, it stores orders that map from the user ID of the customer that we want to protect to the order ID 0. So order ID 0 is the order ID that we want to protect. We don't want the evil client to be able to access that. But what this scenario shows is basically the evil client makes a call to this order. It just passes in the ID of the user, and it's going to get back the order. Right? So, I mean, this is a very trivial attack, right? It's basically the evil client just, being able to guess the ID of the user that we want to protect, and just getting the order ID right away, right? Now, so this seems like a sort of toy example, but actually this represents one of the classic mistakes that inexperienced web developers make, right? A lot of web developers make the attacker is not going to try to guess the parameters to the input parameters to these operations, but in fact, a few years ago, there was a case where Verizon had this kind of mistake, and someone was able to obtain the text history of any user on Verizon just by applying this kind of attack. Okay? So what we wanted to do, fix the system. We're going to try to fix the model and to rule out this particular attack. Okay? And the problem here is simply that in the function list order, there isn't any kind of access control, right? basically the list order accepts user ID, and it just returns the order of the user. But what we want to do here is we want to change the parameter. We want to change the function such that list order now is going to accept a session ID. Okay. The order that, and because the session ID cannot be guessed, because we made an assumption that the session ID cannot be guessed by the attacker, this should actually prevent this particular attack. Okay? So once we do this, I'm going to rerun the analysis. Try to see whether there's still an attack available on the system. Okay? Whether there's still an attack that's possible on the system. And this time it finds different kind of scenario. So it finds a scenario with an evil client interacting with a my store. And in this case, what happened is basically this attack involves. Let me just step through the scenario. So the evil client is going to sign up. The evil client is going to create its own account on my store. Okay. And then it's going to log in, and it's going to obtain the session. So whatever session that's mapped to that user ID, right? The user ID of the evil client. And then finally, it's going to make a call to list order, and it's going to return the order ID. Right? So again, this order ID 0 is the particular order ID we want to protect. Okay? Now, so what's going on here? Why is the case that the evil client is able to access the order ID 0? Can anyone make a guess? Rough guess? Okay, so if you look at the initial configuration, initial information that's stored in the database, you see that the sessions database actually maps the different user IDs to the same session, right? So what this means, what this allows is basically when the evil client performs login and receives the session, it's the same session as the session ID of the other user, the customer that we want to protect, okay? And this is how the evil access the confidential order ID. So again, this is a different kind of mistake, right? In fact, this is a mistake that's not really about access control, but it's really more about the configurations, right? So it's something that you have to make sure is true of your system. When you design, you have to make sure you create a new session ID. You want to make sure that it's not any of the previous session IDs that's been generated, right? Otherwise, this could allow the attacker to carry back. So what we're going to do is we're going to, again, go back to the model, and we're going to edit the model. So we're going to add a constraint called uniquely assigned and sessions. Right? So what it's going to do is going to basically tell Poral to assume that it's never the case that user IDs are going to map to the same session ID. Okay? So this should prevent the kind of attack that we just seen. Okay? And then we can rerun the analysis again. Okay, sorry. I need to do podcast one back. Yep. And then you rerun the analysis and see whether Poral can find another attack. So what I want to demonstrate with this demo is basically sort of two things, right? The first thing is that even if you have a very small model like this, you're still going to find a lot of interesting scenarios, a lot of different attacks that could actually happen, right? And the automation actually helps here, right? The automation is what enables Poral to find these sort of surprising corner cases that you might miss if you're trying to do this manually. Right? And the second thing I want to show you is just this sort of incremental fashion of building and analyzing threat models. Right? You start with a model, and then you run your analysis, you find some attack scenario, and you go back and you fix your model. And then you keep sort of doing this many times as you need, or until Poral finds no more attacks in your system. So I'm going to go back. Okay, so just briefly, accepts two different kinds of inputs. Accepts the model of the system, as you have seen, and accepts the requirement, the security requirement that you want to check. Okay? And it's going to combine those two things with the knowledge it has in its library, its threat library. Okay? And it's going to combine those three things. It's going to compile into a format that can be analyzed by the backend engine. And when the engine finds an attack, a scenario is going to basically translate that back into a presentation that's displayed to the user. Now, so here's some key ideas that makes Poral work, right? The first idea is that just the idea of representing interaction between components as data flow through API operations. So this enables Poral to reason about end-to-end data flow throughout the system. Okay? And the constraints that you write, so those ensures and the configuration constraints you write, are actually the knowledge that you can take to the next phase of your development. These are sort of the specs, your design specs that you need to implement when you're trying to build each one of these components. And the second idea that makes Poral work is the idea that you don't need a complete model to get useful feedback out of the tool, right? You just need to start with a small model. And in fact, less information you give to Poral about the behavior of the operation, more scenarios it's going to explore. This is sort of in contrast with testing, where in testing, if you want to explore a particular behavior, you have to write a test case for it. Whereas in Poral, it's going to always assume the worst case. It's going to try to find the worst case possible scenarios. Okay? And the third idea is the idea of reusing knowledge by instantiating a component as type of another component. So you see an example of this in the demo where I instantiated my store as a type of HTTP server, and that enabled Poral to reason about potential threats on that threats that it knows about server and use that against the my store. And finally, the automation works is basically by translating the description of the system as well as the requirement and the threats into a logical constraint. And it's going to be solved by a constraint solver. And any instance that the constraint solver finds is going to represent a potential attack on your system. Okay? Now, I should also mention that there's a lot of ideas that we are borrowing from based on some of the great works that's been done in the past. The first idea that we're using is the idea of attack trace, which was invented by Bruce Schneider. So here the idea is that the tree shows different kinds of action, different ways in which the attacker could combine. And you can think of a scenario that Poral generates as basically a single path through this attack tree. Of course, there's been a great number of efforts in trying to capture and reuse knowledge that we would have about existing threats and vulnerabilities. And the information in Poral's library is based on the data from these databases. Now, in 1970s, Dorothy Denning wrote a paper which has since become one of the most papers in computer security, most important papers in computer security, where she introduced the idea of information flow framework. So basically, the idea here is that you want to be able to sort of reason about how information flows throughout the entire program. And you can think of Poral as basically instantiating this framework to the component level, so to reason about sort of architectural level issues. And finally, the idea of solving it came out of the programming language community, where people have used constraints as a way of finding bugs, building static analysis tools, and many other kinds of applications. Now, so there are some things that Poral can't do. In fact, there are a lot of things that Poral can't do. First, it can't really check implementation for security bugs, right? This is true in general for any kind of threat modeling tools. Right? There are other tools that can do this much better than Poral. Now, it can't really tell you about attacks that are outside the library, right? So it only knows about the threats that are stored in the threat library, right? Now, again, this is not really an inherent limitation of Poral. You can, if you know about a new kind of threats that doesn't exist in Poral, you can basically add it to the library, and it's going to perform the analysis, and it's going to try to find attacks based on the new information that it has just gained. It can also tell you whether your model is accurate, right? If your model is wrong, then whatever output you get from Poral might not be reliable, right? I mean, basically, it's up to you as the designer of the system to build a model that's as accurate as possible. And what this means is that Poral can't really replace humans, right? You can't really replace human insights and domain knowledge that you have about your system, right? Poral can only Poral is there to sort of help you and automate some of the tedious things that you might be doing right now with threat modeling. So at this point, I hope I convinced you that threat modeling is a useful activity and it's worth the investment. And I just want to also tell you about other tools that are out there that you can use for threat modeling. The first tool is the tool called SDL Threat Modeling Tool from Microsoft. So Microsoft has been leading, so there's a team at Microsoft that's been leading effort in trying to get developers at Microsoft and other places to do threat models, to build threat models. And every year they release a new version of this product that you can download for free. Now, Adam Shostak, who's I believe is also at Microsoft, he has created this game called Elevation of Privilege, which is actually a very interesting and fun way of introducing threat modeling to developers. So if you have a hard time convincing your colleagues to build threat models, then this might be a great way of getting them to do so. There's also a tool called Trike, which is an Excel-based threat modeling tool that helps you enumerate potential threats on your system. And finally, there's a threat modeler, which unfortunately I haven't tried because it's not free. Okay, so what's next? What's the status with Poral? So I've used Poral to model and identify flaws in several web applications. So these are all commercial applications. And in some cases, the result of the analysis in Poral has led to design changes in those systems. And what I'm going to do next, what I'm looking into now is basically I'm looking beyond the web. I'm trying to sort of think about other kinds of domains where this kind of tool could be useful. So Poral itself is generic, meaning they can be populated with any kind of knowledge from different domains. And in particular, I'm looking into applying Poral for medical devices, as well as looking into devices, home automation devices for Internet of Things. And finally, the next feature I'm trying to add to Poral is instead of just generating attack scenarios for you, but Poral can also generate suggestions for fixes, for fixing those flaws automatically, based on the knowledge it has about common fixes that are out there. So finally, so I'm still doing a little testing, but I believe that tool should be released in October. And so I would love you to try out the tool. And if you have any questions about the tool, if you want to know more about the tool, I will be happy to answer. I'll be around for the rest of the day. And I'll take any questions. Yes?
When you were doing the modeling, it was a little unclear when you were able to tell what the specific threat was that you needed to go back to. I mean, because it would say, evil client using this method to get to the store. And so where was it in that interface where it told you what the threat was?
So it doesn't, the threat is basically, it doesn't tell you exactly the kind of threats that is being shown. It's basically, the threat is basically just it's expressed in terms of set of operations that the evil client is going to make. Right? So you sort of have to look at the operations. You have to look at the data flow in those operations and trying to basically understand why that evil client is able to access a piece of confidential data. Okay? So that's a feature that, so it would be nice to be able to categorize a particular scenario into sort of patterns of attacks. And that's something that I can add, but I haven't been able to do so yet. Any other questions? Okay. I'll be around, so if you have any questions. Thank you.
Nice to meet you too. Oh, okay. That's nice. He said he was going to do it, but if you want to do it, the dude at the door? So, yeah. I mean, I don't really... It's great that someone's going to do it, because that really needs to happen.
Okay.
But, yeah, I don't care who. Thank you very much. I really appreciate that. Okay. I can do my fine. Yeah, I just say a couple of things. Appreciate it. Thanks for the help. And anything tricky about hooking this up? Okay. Thank you.
If you don't mind asking, how tall are you?
About 6'8".
Can you see if you can change your resolution? Because I'm getting something weird on the recordings. Like it sounds like that. So
I really don't want to do that.
no? Okay. Well, we won't have the recordings if we don't try some stuff.
Yeah. All right. Let's.
And I don't want to record too much, but
I can try. You want to look at it?
yeah, I'm seeing this right here. So.
It's been hooked up for 25 minutes. There's 3 minutes to go. What resolution do you want?
Go with one that voice that is like smaller, or best for display with this. Yeah, no, it's good. So
Jesus.
If you keep it that way, it's perfect for me.
Let me check that for a second. I'm not 100% on that. All right, I guess we can do that. All right, we'll wait just another minute for folks to trickle in. I'm going to knock that over for sure. Okay, why don't we get started? Hi everyone, thanks for coming. My name's Jeff Williams. I'm the CTO and founder of a company called Contrast Security. And I was for 8 years the chair of OWASP until I wised up. But I love OWASP and it's great to be here. Today I'm going to be giving a talk about continuous application security. You've heard of continuous delivery, continuous integration, continuous deployment. I'm going to try and interpret that for application security and show you how it can work and can be better than what we're doing today. So we'll start out. This is not a basketball. This is a basketball coach. And this is the Wilson 9450. The basketball court is 94 feet by 50 feet. So this basketball has a ton of sensors inside it. The sensors, as you play, the sensors measure the arc of your shot release speed, your dribble speed. It tells you which hand is dribbling stronger. It's even the rotation on your shot gives you all those numbers. So it's actually really amazing. It connects to your phone via Bluetooth, and it gives you this monitoring game. I started using this a couple weeks ago, and it's fantastic. So here's my dashboard for my game. I'm shooting too flat. Like the 9450 has a model of what good basketball looks like. And your shot should be somewhere between 42 and 48% degrees. And I got a couple in that range, but most of my shots are coming too flat. Now, I've been playing basketball for 30 years, and I didn't know this. Because nobody tells you, because they don't care. And it's actually kind of hard to see what somebody's arc actually is. So I think this is fantastic. So this thing has a model in it of good basketball, and it continuously compares your game against the model to give you great feedback on what you're doing. And I think there's a huge lesson here for application security, which we'll talk about today. So really, this is about approach. Sensors plus model gives you continuous feedback on whatever you're trying to do well. And in a lot of ways, it's better than a human coach because they're always there. Now, do you still need a coach? Sure, probably. But now your coach doesn't have to sit there and watch you while you shoot 1,000 free throws all day. You can do that with sensors. You can monitor that. And your coach can focus on giving you strategic advice for how to play. So there's no more, call this approach Moneyball. If you saw that movie, you know it's numeric approach to application security. You can play Moneyball with AppSec. So I've given a couple talks on this that I encourage you to go look at. One was at AppSecUSA a year ago, called Application Security at DevOps Speed and Portfolio Scale. And in that talk, I focused on what makes a great sensor. Like what sensors can we actually add to application security during the development process? What can we measure? What can we do? What can we do easily, actually? And then I gave a talk called Building an Application Security Network, Application Security Sensor Network. And this is about building out an infrastructure to sort of manage those sensors, gather that data together, pull it to analytics, and create those dashboards. So I encourage you to check those out because there's a lot of background there that I can't get into here. But this talk all the way, whole program built around the ideas of continuous application security. Let's take a second first to it's so important and why it needs to change. Traditional application security programs are built around experts and and they're all out there in the hallway. You got tools that, static analysis tools and dynamic analysis tools that basically require experts to set up and run. Application security done. If you've got a big application portfolio, your team can't handle. I've seen a lot over the last, I've been doing this for about 15 years, and I've seen and worked with a lot of these programs. They can't scale across the whole portfolio. Get to about technical ones, and then they have to stop. They can't handle the bandwidth. And the other thing that we're not really producing any good assurance. I mean, we spend a lot of time doing code reviews and running scans. It's a big pile of vulnerabilities, right? That doesn't really tell you that anything is good. It's not an assurance argument. It doesn't give anybody any confidence about the software. These programs are coverage. We talked about portfolio. They also have vulnerability coverage tools. A lot of stuff, particularly authentication, access control, and encryption. Tools can't analyze those, and that's where most of the critical vulnerabilities are. So we're great. And the worst thing, I think, is that application security programs are pissing everybody process fit for software development. They're insulting to developers. They inspire executives and for security professionals. I think we can do a lot better matching up to the process of modern. So, not surprisingly, these programs aren't working, and we're seeing the results in breaches. So, Verizon DBIR report, you should read if you're in this field, came out. It shows 36% of breaches are due to applications. 36% of them. That is by far the biggest category of breaches are due to application vulnerabilities. All these things we hear about in the news, APT, POS attacks, DDoS attacks, insiders, card skimmers, all that, only a percentage of what comes from application security. But what's tragic is that when you look at the spending in the industry, only 1.7% of security budgets get spent on AppSec. You know why that is? Because we suck. We are not explaining the problem well enough. Even in the face of incredibly damning statistics, we're not able to command the budget for some reason. And frankly, I think it's really hard for organizations to spend money on AppSec because it's so difficult to do. So we've got a real problem in application security. We need to figure out a way to do it differently. So I think waterfall thinking sort of pervades application security. Every activity you hear about is tied to a phase in the life cycle, right? It happens at design time or at integration time or coding or goes into production. I think we need to get out of that mindset. I think we need to think more about a software factory. Like, this is a development organization that takes business needs and it turns it into running high quality code, right? And it's continuously working. And so what our job is, we need to figure out how to get that factory to produce code without messing it up, right? We can't just break it. So the sort of the naive approach to doing application security is to put a bunch of gates and checkpoints into this process and try to get the factory to produce something different. But it's kind of ham-handed and it doesn't end up really being effective. Now, it's important to understand that these software factories come in all different shapes and sizes. Small shops, some are agile, some are DevOps, some are process-oriented, some are technology-oriented. There's a massive range, and any of those shops can produce secure code. So I don't think that the right approach going forward is to sort of compare these software shops against each other to see what everyone's doing. I think what's important is that we measure the output, that we actually come up with a way to measure whether they're actually producing secure code. And it gets back to the 9450. We have to have a model of what security looks like so that we can measure against that. And once we get over that hurdle, then we can put sensors in place, and I'll talk about how it works going forward. So a great quote, quote from Zane Lackey at Etsy. He said, development organizations view delays as damage and route around them. So you can instantly see the way that we currently practice application security is going to be a problem because we're establishing delays. We're putting delays into the process in software development. We can't do that. We've got to figure out a better way. And there is one. So I looked at modern industrial factories, right? Factories that build stuff, real world things. And they're littered with sensors these days. There's sensors for, there's cameras, there's moisture detection, vibration detection, got cameras everywhere, all kinds of sensors everywhere through the factory. And the reason that they do that is so that they can monitor every step of the process, corrections to the process. So if a bearing starts to get burned out, it'll create a that part of the factory, and they'll detect it instantly, right? So we've got all these sensors. They all have all these incredible adapters to bring all that data together. You got to get it in a common form. So they've got adapters. So we've got sensors and adapters. They actually do bring all this stuff together into programmable logic. All this data comes together. They make a big database full of all this data. They run smart analytics. That's where the compared to the action. And then all that turns into beautiful dashboards and alerts. So what they've real-time feedback loop. Almost instantly when something goes wrong, they get notified right away. It gets done. So that's the pattern that I think we can emulate in AppSec. Sensors, adapters, analytics, dashboards. Conference I've heard talking about, well, any individual tool is good, but when you put a bunch of these bad tools together, you can get better results. And I'm going to say I'm not convinced. I've tried this of organizations, but running bad tools that have really high signal-noise ratio, that are spotty, that are difficult to use, and that require experts, running multiple of them has significant problems. First of all, it's just harder, right? Every one of those tools that you try to run, you've got to onboard the application, you've got to run the actual test, you got to get the results out of it, you got to tailor, you got to triage on the results. It's time consuming. And second, what's really disturbing is you're going to lose the things that you then focus on the vulnerabilities that multiple tools find, right? Because you think they're higher confidence. But what you'll lose is those tools do really well, uniquely well, right? If you've got a tool that does a couple of things really, really well, you're going to lose those because they're not going to be corroborated by. So that's a real problem. I believe what we need is much better sensors, simple, accurate sensors that do a great job. And so to that end, I'm incredibly excited to announce a new free application security sensor. And it's probably unlike anything you've seen. This is, let me just get on my right slide. This is contrast and some out there. And I just wanted to be absolutely clear. I did verify with the OWASP board. It's absolutely okay to talk about it at an OWASP conference. This is a 100% free tool. So I just wanted to make sure everybody freak out. I'm going to put this tool up here. So I had a little trouble with my screen here. Here we go. So this is Contrast for Eclipse. It's incredibly easy to install. You just go to the Eclipse Marketplace, download it just like any other Eclipse plugin. And what it actually analyzes your application as you use it. So when you start up Contrast, it's going to look like this. Let me clear out. I'm just starting from scratch here. And in order to use it, we've added something to the Start menu here. So I've got a server started, but you just run Contrast instead of the normal Start. Okay. Developers can just run this very similar to the way they normally starts. Contrast the app with passive sensors. Those sensors gather data directly from inside the application. These sensors have access to a ton of information, not just the code, although the request, like a dynamic tool. We have access to all of that and access to information, the runtime data arrays and frameworks that are in the application. We have access to the config files, even all the back-end connections. We see everything that's going on inside the application, and we can make great security findings with all that data. So what I'm going to show you is just a simple web application. I've started this up, and I've got Contrast enabled. So I've got contrast over here, and we'll just clear out any findings because it keeps finding stuff because the main page contrast. And screen resolution is kind of messing this up. So main.jsp here, home.jsp. And so here's the sort of the main app. Contrast has already started analyzing this application, and I think if I go to register, there's a whole menu here. You know what? I'm just going to go over to this and just register. This is the same application running. It's just an external browser as opposed to an internal browser. I'm just going to register, put in my name, Jeff Williams. I might have mistyped that. Whatever. Chicago. Credit card. And submit that. Contrast analyzes that request in real time, and the results show up immediately in the Contrast for Eclipse plugin here. So then, let me make this full screen so you can see it. What we're seeing here is a trace for a cross-site scripting problem discovered in this page. And I'm going to slide so we can see the whole trace. What we see is the exact line of code where this data came into the application, the request.get parameter. We can see some other come into the application. We can see all the transitions as data is built and then finally sent out to the web page. Canonical cross-site examples like this. Since we have all this, we're right in Eclipse. You can click on the line of code and go directly to the exact line of code. So notice this is in the person class here, and we trace it through profile.jsp where this data gets split, and eventually down to the line of code where this gets written out to the HTTP response. So really detailed information. We actually have all the stack traces. So you can see, here's the actual runtime data from the container. If you're a developer and you really want to track this down, the full HTTP request. This is a real differentiator because static tools only give you lines of code, but they don't give you a test case. So you can never really know if it's real. Dynamic tools only give you HTTP information. They don't give you the line of code, so that's hard to track down. Contrast is running inside the app, so we have of those pieces of information. So we can give you a really full-featured finding that will help you find and remediate this thing. So we've got a bunch of details. See, guidance on how to fix it. There's a risk summary. But this is a free plugin. Every Java developer in the world, as far as I'm concerned, should be checking their code with this before they check it in. Because we've lowered the burden of doing application security checks to almost zero on developers. They can do this over and over as they run. This thing is actually real time, and let me give you a demonstration of that. This is Selenium IDE. This is a Firefox plugin. Easy way to build cases and scripts that exercise a website. So all I did is I hit record here, and I just clicked through the links and menus in this ticket book app, and then save that. And now I can just replay that whenever I want. So what this does is it actually just exercises. You can see contrast is running at wire speed here, and the vulnerabilities are just pouring in plugin in real time. So we can look at this. Let's look at the evidence because that will show you exactly where it happens. This is .jsp has data, and then it writes it out. It calls it in the runtime. We can see all kinds of vulnerabilities this way. Down at the bottom, you can see vulnerabilities. So we're actually analyzing all the libraries and components and frameworks that are part of this application and giving you data on whether they have known vulnerabilities. This is sort of OWASP top 10 A9. Give you coverage over that so developers can instantly say, oh, I don't want to better update my library to. And the analysis that Contrast is doing here is actually pretty sophisticated. The entire, not just the source code, but the entire application, all the libraries, all the frameworks, even down to the Java runtime, we track the data wherever it goes. And what that is, that dramatically reduces the traditional tools get. When we track through the application particular string, so we don't have to guess. We don't lose track strings when they go into collections or when they move around and get sliced and diced through an application. So this using here application security testing. And it's the idea of using instrumentation to find vulnerabilities like this and sort of real-time continuous feedback to folks. So I encourage you to check out this Contrast for Eclipse plugin. Give it to your developers, see how they like it. This is a brand new tool on the market. It's a new technique, and we're absolutely looking for all feedback we can get on, does this work? Does developers a really great sensor for application security problems? Does that allow them to check in secure code? We're hoping that it does. Okay, so let me go back to the presentation here. Right, that's a great development, but it's not a whole application program, and I would never try to claim that. Putting in a single sensor in sort of one part of a development organization, the IDE, isn't going to solve application security for everything. I really think you need to instrument that whole software development factory, not just the IDE, but all the different systems and processes that code goes through before it gets to live. Really, it's trying to get that culture of instrumentation to catch fire within your organization and get people to rely on it. So the good news is this is already happening within your organization. So lots of teams are now, who's doing some variant of Agile or DevOps software development? Right? So, it's like at least half the room. These processes rely on instrumentation to produce high-quality code. And when I first heard about XP and Agile and DevOps, I was a little skeptical, right? I was like, that's going to be a disaster for security. But it turns out I was 100% wrong, 180 degrees on this. So with traditional sort of waterfall models with rare release cycles, your project can get way off track from what it's trying to build before there's sort of a correction back to the model. And that introduces a lot of risk. The farther from your model you check and get back on track, the worse off you are. With Agile and DevOps, those cycles are much shorter, so you've got many more opportunities to and stay on track, which results in a lot less risk. So I was talking to Nick Galbraith from Twitter a few weeks ago, actually. We had a great conversation about this process and why DevOps is good for security. And he said something interesting. He said, these continuous practices force software development shops to establish the infrastructure to measure software automatically. Right? They build the infrastructure to do automated model testing. Whatever they define as quality, they test it automatically, and they've got the infrastructure to do it. So they run Jenkins, and they run all their unit tests at continuous integration time. Every time you check in code, all the tests run. Because they've provided the infrastructure for organizations to do great applications. But it's just an opportunity. It's not a guarantee. DevOps is not going to produce secure code just by itself. But it gives us an opportunity to software process so that it will produce secure code. And I like Dan Kaminsky's quote here too. He said, to survive this, meaning he's a little more apocalyptic about the way software development is going. To survive this, we have to monitor, we have to report, and we have to adapt in real time to our mistakes. And that's exactly what I'm talking about here, is how do we adapt to our mistakes faster? So my colleagues at AppSecUSA have spent the last year working with client continuous AppSec programs. Basically what they did is they started out with software development and Agile, mixed in a whole bunch of application security practices. And they got these practices from all over the place. Historically, like the Orange Book and the Common Criteria, the maturity model, 90s, looked at all different approaches to application security. Through a way, they contribute to security. Right? That's a key. It's got to be related to getting close to that model. Anything that doesn't scale, right? Anything that's not real time, so sort of instant feedback, anything that's irritating, and I don't know how to describe that better, but anything that's going to alienate everybody and wreck it. And anything that's tied to a particular phase of the life cycle. And so for example, some things organizations try to do or think they should, security requirements and security architecture diagrams and to some extent threat modeling diagrams. These things don't meet a lot of these criteria, right? And frankly, I can't think of a lot of projects where I've gone to where all the developers are intimately familiar with the requirements and the architecture diagram. Those practices just really aren't working at DevOps speed and portfolio scale. So, and we refactored it into a model we call continuous application security. And we put together this handbook. It describes practices of application security. It's 8 activities that are designed to augment existing software processes, not replace, not change, not break, but augment existing software so that they can do continuous application security. Relies heavily on automated sensors. It's performed continuously throughout the organization, so it's not something that you do at a particular phase. It focuses on whether the security's been achieved. Really, that's the focus of continuous. And what we've tried to do is make sure that experts are not involved in the critical software development path anywhere. And I'll talk a little bit more about that as we go forward. So these are the 8 activities in continuous AppSec. And today, we've got to focus on the middle 3. Because we just don't have time to talk about everything. So these 3 core activities, their whole purpose in life is to create a tight feedback loop. Remember we talked about the 9450? You got a model, you got sensors to measure, and then you've got visibility dashboards to present that data. That's what we're trying to create with these 3 core practices. And so those 3 core practices are probably enough to get all the rest of this done. They'll sort of happen naturally. Once you infect an organization with continuous metrics, the rest of these things will probably happen. But let's dig into these core things. So the first practice is instrument everything. And so you remember the software factory. I want to see instrumentation across the whole development organization. It's actually pretty easy to make these sensors. You can use existing tools and wrap them so that they run continuously at various phases, various places and phases within the software development organization. So for example, you can use a tool like ZAP, OWASP ZAP, which is a great tool. It's, most people use it as sort of a pen test tool, a proxy, but it can run passively. It can sit as a proxy on the network and just passively detect vulnerabilities. So why not deploy that into your test region, get your testers to test the application through ZAP, and get great data about how your application actually works. Monitor the HTTP headers, great. ZAP can watch those. You can build custom tests into ZAP if you want to monitor for is supposed to generate a CSRF token that looks like something. ZAP can verify that for you. There's a language built into ZAP called Zest, which allows you to do things and run them continuously. And that's, once you set that up, that's basically free, right? That's just going to run continuously. You didn't have to do any extra work. You didn't have to pen test, run any. You get all that data for free. So what you're doing is then you've got, right now, you've got a whole bunch of complex tests that you need to run. You can knock off a few of those and turn them into sensors that run continuously. And slowly, we're going to shift from these complex manual processes to automated non-expert processes over time. Then at the end, there's probably going to be some things left that you need experts for to test because they're just that complicated. I think you can probably automate almost anything if you work hard enough at it. But there's probably going to be some things left that you want experts for. That's great. But you've automated everything that you really can. So to make a sensor, what you really have to do is take that tool, wrap it in something that will run it continuously, like Puppet is a great choice. Push out sensors and get them to run on a schedule. You also get data from those tools and turn it into some kind of those adapters that we talked about in industrial factories. So you take all that data and bring it together in some kind of data warehouse or data hub where you can actually analyze it and use it then to create the great dashboards. So, what just happened? I think I went twice. I like what Alex Stamos, he's the CISO at Yahoo, said about this. He's like, everybody's trying to sell me pizza boxes with some fancy technology in it. And what I really want is I want software sensors with centralized intelligence. That's what I'm talking about, right? Software sensors that monitor applications as they're being developed and in production, that generate this data and bring it together so we can make smart decisions. And I like what it says right on the 9450 here. It says the ball don't lie. That's what I'm talking about with these sensors, right? This is data that nobody can argue with, right? It's not a judgment call. It's just data that's coming in and creating a great dashboard that everyone can rely on. Gene Kim, who's the author of the Phoenix Project, which if you haven't read it, you really ought to read it because you'll recognize a lot of your own organization in the book. And he's got a lot of great lessons about how to think about the changes that are happening to the way software is built. But he had a great quote. He said, if you have code that's important enough to deploy, then it's important enough to instrument. And I absolutely believe that. I think the future of software is that everything's going to be instrumented. And I wanted to talk about a company called New Relic. Is anybody familiar with New Relic? Okay, so what New Relic is, they have a sensor that monitors performance of applications. You just drop it in your application, and when you run your application the normal way, it produces great data around performance. It times everything, back-end queries, request times, everything, and gives you a great dashboard. You don't have to do any extra work to get this, but what they did is they changed something that was an expert-based field, like AppSec. They changed performance engineering, which was like expert-based, into something, and that's what sensors can do for application security as well. And really, that's the only way we're going to scale it, because we've got way too much code and way too few of you guys to do this job. So this really isn't for just the unicorns, the Googles and the Etsys and the Twitters and the giant monsters. Anyone can do this for themselves. So the second practice is make security visible. We talked about sensors. Now we've got to make that data visible, right? So we need some analytics and some dashboards. So all those sensors, pull it together into some, we're going to create some great. So the folks at AppSecUSA worked with a financial organization that, when we started, they were basically doing triannual manual reviews on applications. Triannual reviews. And so their data was really spotty and really out of date. And what we were able to do is integrate some of these sensors into their software build process and gather some great data to give them instant feedback that's always up to date on these applications. And it's absolutely working and helping. Money that they would have spent on penetration testing is now being spent on creating sensors and automating. So it's been transformational for them in a very short amount of time. So they're on a great path. I wanted to show you a couple dashboards that I'm familiar with. At Yelp, this is a cool dashboard. If you're familiar with content, the XSS prevention that's built into certain browsers, there's a way for CSP to give the application feedback directly from the browser. So Yelp is receiving thousands of reports a minute from CSP that's coming back in, and there's a ton of useful. It's essentially a sensor that they've deployed, and it's telling them what's going on in their their huge array of applications out there. They've got a nice blog about it. The URL is there. But this is the kind of dashboard that developers can really use in real time and see what's going on. So another slide is Etsy's dashboards. And what they've done is this is Zane Lackey's quote. He says, you should surface security info for everyone, not just the application security team. And he's adamant that by making this data visible, it changes everything. The whole tone of security in their organization is different. Security guys in application aren't confrontational. And they look and they see problems, and they say, what are we going to do about that? And they think about it, and they solve problems, rather than sort of arguing and trying to call each other out and sort of self-aggrandizing themselves. So I really think that making these dashboards is incredibly important. And again, anybody can do this. This is one that we threw together for the talk that I gave last year. This is nice. We run some simple open the data together, and this gives you nice letter grade scores across a lot of different categories of security. I definitely encourage you to build a network. For this, we use Puppet. So Puppet pushes out the sensors to the various app servers for running. When they run, the data gets collected and it gets pushed back to what I'll call an application security data warehouse, where the analytics happen. First, all that data has to be, we call it digested. The data has to come in, and it comes in various formats, right? Some tools produce text, some produce XML, some produce ML, all kinds of. What we're going to do is sort of standardize that. So all the data is coming in a standard format, and then you can pull it together and make some really nice dashboards. Now, that's all great, but I want you to be smart about what sensors you put out there, right? You can't just grab a collection of tools, just take a collection of tools and just run them and think that you've covered everything, right? I want you to take control of security. And what that means is establish an expected security model. What that means is you've defined what you expect applications. Just like the 9450 has a model of what my game is supposed to look like, we need to have a model of what application security is supposed to look like. And it's not that complicated. For any one of that you believe you want in your security program, like start with the business needs, push down to security strategies, and then translate those into specific expected requirements. Like I would expect in my organization that all the encryption is done with AES. That's a simple statement, but your organization has that policy in some manual somewhere, and I'd be willing to bet $1 zillion that you're using all kinds of different encryption algorithms when you actually get into the code and look at apps. We see time is that the standards don't match what's in the actual applications. So this would be really important. You want to evolve your model. Now, a lot of people would say, well, we should start with the model. We should get a really detailed because then we'll know what to build sensors for, and it's all very logical. Unfortunately, it doesn't really work. Nobody will pay for that paper exercise to build the model and build this abstract stuff because they've seen it too many times before. So what you need to do is start with sensors. Start with great sensors your organization. Then once you get some real data, then the holes in your security story will be obvious. The gaps in that data will be obvious. Like, oh, I see you're checking for AES, but you're not checking for CBC and ECB. So we had to extend that check a little bit. Things like that. So this model evolves over time. And the way I like to think about this is if you imagine sort of most organizations, if you look at the circle, their expected model is really spotty, right? You're probably tied up in some documents, some content repository somewhere. Maybe it's in the tools that you use. Maybe it's in your pen tester's head a little bit. But there's no sort of one place where you can go the whole model. Then on the other side, the things that you're actually measuring aren't very clear either, right? So you hire a pen tester, some stuff, and they probably didn't check your expected model because there wasn't like one document. And so you get all this mishmash. What you end up with at the end is you really know whether you're secure. You've got some requirements and you've got some stuff that you tested, but it doesn't match up very well, and so you just have to decide, like, well, I guess we'll go live. I don't think that's a great way to do something. Trying to get, CAS is all about getting out of that. So if you look at those 3 core activities, they're designed to get that feedback loop started. Sensors, dashboard, get visibility, and then model to make sure that you've got the right stuff. Focus on that. All the other things sort of start to happen. I will go through the other 5 really. The first one is you have to know your enemy. So you should be constantly monitoring the threat. And you can do that through OWASP or other organizations, but you need to stay on top of who might be attacking you so that you can update your model with that information. You need to implement strong defenses. And you could do application security without a set of common strong defenses, but I wouldn't try it. Application security is pretty complicated already, and by standardizing your defenses, by establishing your own enterprise security API, you can simplify both your model and the implementation of that model. You got to make it simpler, otherwise this stuff is just too intractable. So, I've talked a lot about that standardization of controls, and it's really, really important. You should hack yourself, and I think it's important to constantly be looking for the gaps and flaws in both your story, your expected security model, and new and novel flaws in your implementations, right? So there's always going to be a role for security researchers who are doing great stuff. But again, I want them to focus on the things that you can't put sensors on or you don't know to put sensors on yet, right? The people in this room should not be testing for XSS and SQL injection and the simple stuff. We need to automate those things. And I was in a panel yesterday, and one of the panelists said that application security folks need to be coaches and toolsmiths, not directly involved in the critical path. So we need to make, one thing you can do right away is you convert your penetration testing practice into creation of sensors. So if a pen tester finds something, don't let them give you a PDF write-up of the flaw. Make them create a sensor to test for it for then on, right? Give me a script that I can run on. I'll test this forever. Over time, you'll shift over to all sensors, and you'll be just testing the really novel, really weird stuff where security researchers are necessary. That's what Mozilla has. When they take bug reports, they expect them to come in Zest, that ZAP scripting language I mentioned, right? That way they're reproducible, and they can run them as regression tests forever. This practice is about expecting failure, and really, you know, incident detection, incident response is really important. You need to do it continuously. It's really part of your defense strategy, and so that's part of continuous AppSec. And then the last thing is, I think that you can do things to promote security culture. Training and e-learning, I think, are some of the most effective security practices that you can have in place. But there's other things like memos and promote internal marketing and promotion that you can do. I actually don't, you know, if you did all the other stuff, I don't think you'd need to do very much of this. But frankly, I think it's a great practice to make security culture really take hold fast. And that's it. Those are the 8 practices. You really don't to chase vulnerabilities all day. You can be more of a coach and more of a toolsmith. It really is a new world. I believe that all the data that we need is sitting out there in our development organizations, in the code, in the tools, in the practices. All we got to do is gather it up with great sensors that can find it. And today, I think we've given you a very powerful sensor. The contrast for eclipse sensor, I think, is really powerful. We want to try to get it to every Java developer on the planet because why not? And I could use your help. I want to try to spread the word on continuous application security. I think it's really important. I think it can change the way people do AppSec. And so if you're interested in helping me, please contact me. My contact information is on the next slide. You can reach me there or at Twitter at Planet Level. And the reason I'm here, by the way, is I want to meet you guys. I want to meet everybody here. So please come up and find me and talk to me. I really get a lot out of that. So stop by our booth, pick up the, copy of the handbook. I got some up here. And don't forget to download the Eclipse plugin and give it a spin. It's a lot of fun. I really like it. So thanks for coming out. I'd love to take any questions. Yeah?
About contrast for
we're going to see how this goes. I mean, the Eclipse is by far the biggest IDE, but no question. There is a way to sort of already use it with IntelliJ. Well, we can talk about that. But we'll do the integration if people really like this.
How about contrast for Visual Studio?
Same thing, man. We can't do everything. So this is an experiment. We don't know if developers are really going to like it. So let's try it. Let's see if this changes things. Yeah.
So does the tool actually inject code automatically for developers? Is that
Yeah.
how it instruments it?
Yeah.
So
So
developers don't have to type in extra lines and stuff?
they don't have to do anything to their code. And I'll switch over and put the tool back since people seem to like talking about tools. Yeah. So we're just sort of constantly monitoring the code. So as the bytecode loads, it actually instruments the code. So it adds passive sensors to the actual code. So the developers use their normal process to develop, their normal testing process. They don't change how they work at all, just like 9450. And it gives you great dashboards. How you doing? That's what it does. Yes? Say again? Right now, so the underlying technology does work on client Java. The way the Eclipse plugin is set up, it's designed to work with servers. But if that's something that you want really bad, let me know, and we'll add a a run as application with contrast. Yeah. Then contrast can't see it. So you should, if you're interested in getting really good coverage, you should use a coverage tool like ECLEMMA or something like that to measure the coverage over the code. Both dynamic tools and static tools get terrible coverage over the code base. There's a number of reasons for that. Static tools don't look at the libraries, so it's like a huge chunk of the code. Dynamic tools can only see what they see. Contrast, actually, just by using the application normally, contrast covers a good percentage of the code. In our experiments, we found the code coverage is much better than you get from traditional tools. But it's not perfect. I mean, we're not saying we cover every line. You got to write some test cases to exercise your code. Any other questions? Yeah.
On XSS, it did flag that. Does it do anything on the JavaScript side? My guess is
no. We should talk later about that. But instrumenting JavaScript code is possible, and we're exploring that. Yeah. You have to use the code. Now, normally, when a developer is working, they're normally writing some code and running it in the browser, writing some code, running in the browser. So they're going to exercise the piece that they're working on really well. That's actually really important, because they probably don't care about the other, million lines of code that are out there. They really only care about the piece that they're working on right now. And so contrast will show them the vulnerabilities in the chunk that they're working on. So in a way, it closes that feedback loop in a really nice way. The static analysis tools, you get a 700-page PDF report, and somebody has to go through and go, well, oh, this one is Joe's, and that one's Mary's, and it breaks the feedback loop. Contrast has that right there feedback loop. By the way, we work on huge applications, up to 20 million lines of code, no problem. Oh, find bugs is a static analysis tool. It doesn't do instrumentation or runtime. It's a different technique for trying to find flaws. Yeah, so I'm getting kicked out. So I'm happy to take any other questions. I'll be at the outside the door at the contrast booth.
Okay. Yeah. At first I was thinking like, take this jacket off, stepped in here, like, no. Sit in these rooms for a while and, you know, especially if you like sit here, then you go outside of the building, like, poof. I'm originally from the Netherlands, but I live now in the UK. I start to notice that people started out like, I hear you're not American, although you have a slight American accent, and you've got a British accent, and you've got a Dutch accent. Where you're from? Yeah, oh, that's easy. That's easy. I think it will start changing, like saying where I'm from, more like I'm from Europe. Like, forget it. Same thing I have with a lot of Americans, like, where are you from? No clue. Or even states. I thought that like Nebraska was always more north towards, so it is a state above Nebraska, closer than or two. Wow. Which makes it easy to remember that one. Like you and Dakota above. There are two Dakotas. Dakota. Comfortable? Comfortable? I start to believe that this is about it. Two after? I've seen one more. It's not like a big rush coming in at the moment. With my presentation from the ground up, well, talk about a little source sync tracing within the JVM. My name is Steven van der Baan. I'm Dutch. I live in the UK at the moment, as I work with 7safe and, according to my wife, also for OWASP. The project that I'm going to talk about started about a year and a half ago, where I was talking with these two guys, Jim Manico and Dennis Cruz, about source sync tracing, and that the string class actually is too permissive within Java. Also that, for example, with the all HTTP requests, we know what is our allowed values, we know what type of lengths in there, and still we use the strings to communicate with it. And we should find a way to, or add a way to maybe the class and give it the so-called evil bit if information comes you do not trust. Well, when after talking with these two guys, they told me, well, if you feel that passionate about it, prove that you can do it. And I managed to do that in this time immediate. So that's why I'm now here talking about that little project. So the that I had was that that will enter into your application will be marked with a so-called evil bit of your application. It will check, does this string contain the evil bit, and yeah, we'll make a warning in some sort of fashion. What I want to add to it is that the application itself cannot be changed whatsoever. You should just take an application and this should be marked within that. So from that point it's more intended towards also that can test the application in the staging environment, not bothered with production, etc. So when I started in my quest to discover, like, how can I do this type of tracing, there are a couple of technologies that I first was manipulation. But then you had to change the boot class. IOP, but especially with reflection, and trying to do that in a dynamic way is quite challenging. Or agent, like JRebel does, or last combination was the two, having to manipulate it using Java agent. Wanted to go through the Java agent route, but I discovered that you cannot touch the string class as if Java agents are loaded after the boot loaded. So I only just then went for that one route that was left, that is the full bytecode manipulation. And also, like Zap says, that his technology, it is designed by people with, but especially to use by people that are within the testers or DevOps and those type of people. They should to use it and test it is secure or not. So back to the idea. Here you see the first test class that I made just to have a proof of concept to work with to do. A simple read from the, your input in a buffered reader. You put in a name like, what is your name? You read the simple hello, that's your name. Black when you see it, when you do it. My name's Steve. Second one, I add backspaces into it, and this also again shows the permissiveness of accept all those backspaces as a valid character. So So when you output it again, it will override what was before it. So you see, also already on this type of level, you can hack the output what is shown. So, like I said, my intention was then to use it underneath your application to have there the definition of what is an evil string and make that parsable throughout the application. So when it really enters your application at the other side, you can have various checks and gates to see this evil string leave your application. I have to warn you, after this I will show a lot of snippets of code of everything that I've done. So that's the premise of how I will show you. So first is the tainting of the code itself. What is the basic where you start to work with? So the first a couple of basic classes that you have to manipulate. First of all, the string. As I said, the string is the type of class that I want to follow throughout my application. So I have to give that a particular method tag so that I can demonstrate this is a tainted string. The other one is the string builder, because string by itself doesn't do that. Every time when you concatenate or if you do specific transformations on a string, underneath string builder is being used. So changed as well. Because I want to have a bit more dynamic finding, like where are my sources and where are my sinks, I also class loader a little bit. Because the class loader, all classes that are loaded into the JVM first come in as the bytes, and they are instantiated by that particular class loader. This also applies to classes that are loaded through the reflection technique. If you touch the class loader, you will have the default point where classes will come into your application. And as I said, at the moment, it is a fairly small application which I have. I have a generator which will, as I show later, generate the various base classes, some utility classes, and that's the base add into the bootstrap classes. So how do I build it? As I said, first I create my project classes. In that I manipulate the base classes, the string builder, class loader. After that, support classes. The last step I do is to create a jar to use it also with other. And for the string, I JavaSys, because that is a extremely powerful on the bytecode manipulation. As you see, you can use simple code snippets. It also has a couple of predefined getters and setters, which make it easy to define what you want to add to a particular class. As you see, I first add just a Boolean value to mark if something is tainted or not. And I'm using the fact that the moment it is instantiated, it will default be false. Also added the stack trace element. So if I have a location where a string comes in and I mark that one as tainted, I also will set a stack trace into this position so that when it enters, I can immediately say this is where the string was created, and here I am when it goes out. Write that to a file, and you can use it as a separate class. Same also goes for the class loader, although there they use a lot of method inheritance, so it was quite tricky to first find out which particular define class I had to use. I managed to find that it was the one with the longest amount of parameters in it, so I had that one so that I can just process any classes before it's given to the last stage within the class loader. I can wrap it if I want. But I have to be careful that I'm not wrapping everything. So I already start for little class files, like are they the ones that I don't want to wrap at this moment? So use the normal one. But if it's one that I am interested in, I will check on a couple of levels. Have I defined this is a class that I want to instrument, then modify it? Or does it implement a particular interface which I'm interested in? You have to modify it, extend a particular abstract class. Then I want to modify it as well. So, like I said, if the class needs wrapping, I chose the XML format to check it against the interfaces or parents, and this will contain then all methods that can be labeled as sources or sinks. And this is how the moment looks like. As you see, a simple setup where I have a couple of sources in it, a couple of sinks defined, and on the bottom one I have stuff which is checked more on the runtime. So when you go to the proof of concept that I showed earlier, then more into a test, unit test type of setup. As you see, the readline method within the buffered reader, that should be considered a source. With every test class, I use this particular get username function, so I am always sure that this will be a tainted string as a result. And this is within the Gradle method, the way on how I check it. Just all the classes that I had generated for that particular class, I prepend that on the bootstrap class path. And I will use the throw exception at this moment, because within unit test it's easy to capture. These were the test classes. The first one is just a simple the input-output. The second is where I used string, and the third not like 3 minutes. Long live flag of past where they when that happens with unit test. Same goes for if you want to do SQL. The execute query which accept a string, they will as a sink. As you see in the test class, I again set it up everything a database for everything to compile correctly. But the moment the execute query is being hit, that's where the exception is being thrown, which is expected by this particular test class. And so I can at that point that this tainted string was they try to get out within the execute query. Yeah, the fail actually should be up, but it's my way of writing first nicely closing or everything, and then yeah, you shouldn't reach this particular point. So that's why it's there. Like in case that goes wrong, I will that everything is closed. J2EE, yeah, fortunate within the whole J2EE, that particular stack is like a subset above your web application. So that means that the J2EE environment really is, as they are dependent on the bootstrap classes, you can instrument them as well. Unfortunately, at this moment, I cannot do it for JSPs. The internal test runner from Jetty, and every time I get a particular error, it just says exception without any method at all. So it will be a nice challenge to discover that one. But the code that is generated by it, if I make that into a servlet, it will pass and still tell me that the whole request output is perceived as sync. So it's technically possible. This is just a little hurdle that I found on my way and still have to fix. The only difference with the J2EE type of testing is that you can't use the exception, because the moment you have an exception, the whole servlet, the container, will stop running, and it will not then reach particular other points. So I just say, like, do not throw this particular exception, but log it in the outside. And as you see within the particular test case, that the obtained exception was logged in the system.out. So you can still. So, like, I did J2EE, and I started to think to myself, why should I stop there? So then I started for various other JVM languages, Groovy, Scala, Jython, JRuby, Rhino, because they are all running within the JVM. So technically they should also to be tested with this source sync method. But it gives, for every language, it gives a new challenge, how to discover where it goes, where it comes from, and how you should annotate those particular methods. But still, as I said, name those particular languages. They are wrapped underneath your particular application, like a J2EE application. So if you then take a Groovy, quite a language, the top is the Groovy, the proof of concept which I had, which just reads the contents of a file and then does a print line of that file. Like I said, it's extremely basic, but it does prove the point. Can you identify the sources and identify the sinks? I first thought it was with the default Groovy message, like the get text, as that is a valid method within the Java I/O file. Although when I started to decompile it and use JD GUI, I discovered they use the cast to string type of method. So the moment I started to use the short type handling from an object to cast to string, that as a if I identify that as a source, then everything again goes correctly. As you see, I'm using an end script in that particular way, where I just call the Groovy with all the particular Groovy class paths. So I'm not relying on the whole Groovy environment. I just deconstructed executing the Groovy, which boils down to the simple Java executing. And then, as you see here, it says that taints are detected. The reason why it says it's multiple is because every time, also within the string builder, I do make these mentioning that string which is tainted. Maybe I should do something from this point as well. Scala, another interesting language, as it has a completely different, but they're a functional language. Simple, again, a simple read, makes the string out of it, close it, and do a print line of it. Again, fortunately for me, the source was easily defined as the Scala io.source class, and in that the make string. And again, with end, I executed it. Simple, and again, also there. A particular file that I use as input does contain a couple of backspaces, Because as I make that as the point wrong, this is something that you should avoid or test against. That I did for now was Jython, where again I open a file, read all the lines, and print. Then again I execute it through the Java with the particular JVM arguments. I give it the particular Jython Python code, and also there the taint was detected. So as you see, all those various JVM languages, because they are running on top of all the bootstrap classes of Java, can also be traced in this particular way. So what are my intentions to go forward with this one? First, getting JSPs to compile and run and test as well. Nothing bugs me more than running into a particular exception and not be able to figure out why it happens and why can't I fix it. Maybe also think of doing it with Java server faces to see if the same rules, the same principles applies to those areas as well. JRuby, my next target to include in the whole JVM, although I assume that that will work out. The next thing is that we'll start to more optimize that the outputs that will be given will be more valuable. At the moment I either give you the full stack, but I wanted to give it a bit more substance, that really you can see this was the stack trace where it started. Here's, for example, went through a string builder, so it was a little bit manipulated, and here's when it went out, so that you can follow it a bit more precise, and maybe use it with a sort of graphical interface, because that's easier to and more beautiful. There are some projects that are similar, also in this particular thing. Java Vipasa does a bit the same like what I do. The difference, what they do is they change the first character of the string which you have, but they shift process one character on, just that they have their own taint identifier placed in there. The GSR 308 also tries to help you in this, but they are more on the coding level. They're not on already available applications, so I see it a bit as it's a nice feature on to help identify where are potential problems with source and sinks, but this is only for future applications that will come, not for applications that are currently running in your environment. Core as well, and also the contrast that Jeff Williams, which was before me doing his presentation, they also do the same job. They chose the Java agent route. Are there questions around this project? How long did it take to figure this out? I'm not doing it full time because my job and my wife also want to have some spare time. But I think last year I was working on it. Sir. Yeah, I did think about it, like to have an additional check, like okay, here is it cleansed. The only point is I can't make the distinct identification. Is it cleansed correctly and appropriately for the particular sink? Because they can make their own. They can use, for example, a SAPI, where you know this is type of cleansing for these outputs, but they staying within ASAPI, you have like HTML encoding, JSON encoding, and it only writes to a particular output. You can't see from where it writes, in which is it be written in a HTML attribute or an HTML tag. Distinction. So I am thinking of making it a tag like, yeah, they're doing something with it, but you still have to check, is it the correct sanitation on it?
Sorry if I missed it because I was on and off listening, but will you do an OWASP project with it? In order to
Yeah, I will turn it into an OWASP project. And
put the links somewhere, or is it made, or it's not made yet?
at the moment it's on GitHub, but I am planning within the next month to make it an official OWASP project and and announce it like that. No problem. Other questions? No question? Thank you for your attention.
Rock in Texas. Welcome to AppSecUSA here in Denver, Colorado. It's been a long week. I hope you've had a successful conference. There's been a lot of great talks. I hope this is one that you'll enjoy. OWASP A9 a year later, are you still using vulnerabilities? It's interesting for me to take a retrospective at looking at OWASP A9. Those of you that aren't familiar with you know, I am not a huge fan of referring it to as A9 because, you know, I know that there's a top 10. But I probably couldn't name what's number 3. A9 is really last year when we looked at the fact that we're realizing that the way we build software is really sort of fundamentally changing. I say that because we build less and less and we assemble more and more. We have very little insight into what's truly in our software. And I don't say this lightly because, you know, I'm a developer myself, or I sometimes pretend that I'm a developer. I don't get to develop that much anymore. Every time I try and develop something, you should be on a plane someplace. So I don't get to write as much as I used to, but software has gotten so complex, even in the software that I used to understand how it worked, that now I look at the average application and there's very little that we truly understand what's in there. I look at components like it's like the train of software development. We can't get people off of it. Right? The train has already left the station. Developers are enough of it. Oh, I need to do logging? I need log4j. Oh no, log4j is no longer good. I need log back. What should I pick? Should it be struts? Should it be stripes? Should it be Spring? Should it be drop wizard? Oh, drop wizard. Should I use Tomcat? Should I use Jetty? Should I use XML? No, should I use JSON? Or no, should I use a compressed JSON? Oh, there's just so many choices, and developers want to choose them all. Oftentimes, they are all in your application. I wrote a white paper several years ago about dependency injection in Spring, and I mapped out the request of when a user types something into a web application, by the time it gets to what the developer application, how much other code did it go through in the Spring library? And I threw it up in I think it was like an OWASP session in New York. I threw up the dialog box of, here's the control of a web request through Spring. How many people use Spring? Lots of hands go up. All right. How many people understand that this is what Spring does? Nobody has any clue. But they can't get themselves off the fact that I'm going to leverage these components. So not only are we still using components with known vulnerabilities, but we really don't even know what's in our software anymore. And we really should begin to sort of wake up to the fact that we are getting less and less visibility as we add more and more features of what's truly happening in our software. You know, the reason why we have AppSec conferences, AppSec is the fastest growing software businesses, is the fact that things are getting more and more complex. I mean, I don't know if any of you saw the talk yesterday on the top 10 hacks of 2013, right? I mean, I look at that, I'm like, oh yeah, we've got no hope, right? There's some guy who's going to spend his next 6 months figuring out, oh, if I blink this image and I do it this way, I can subvert this technology that nobody knows how it works in the first place. You know, it's like we think we got rid of these attacks or these vulnerabilities and they get. I thought that we got rid of, you know, dependency injection, but we keep adding. I did a search when I first started at Sonatype. I did a search for web frameworks. Right? What are web frameworks? So I did your basic Google search. I want to write a new Web 2.0 application. So what should I use? Right? Of course, it takes me to Stack Overflow. And it's like, oh no, you should use Spring. No, you should use Stripes. Hey, well, I heard a couple of my friends are using Drop Wizard. Another guy's like, oh no, Stripes is the latest, coolest thing. Well, the problem is that each one of those reintroduces the same things that were learned from the previous framework. So it's this never-ending battle. So one of the things that we did is to sort of put this in context of we announced A9, or A9 gets announced as part of OWASP last year, and have we begun to move the needle at all? So we have a survey that we go out. It goes out to about 3,300 different developers that ask them a bunch of different questions. And I wanted to use that framework of that discussion to sort of talk about, are we moving the needle at all? The interesting thing about here is, I mean, there's a lot of stats. Some of these I'll drill in a little more detail, is that we have increased awareness, but there still is that general state of apathy. Oh, it's this thing? Yeah, I've heard. Yeah, I'm kind of concerned. Yeah, that's a tomorrow's problem. The reality is that, you know, if you don't know what's in your software, it's a today's problem. And if you don't realize that you're using open source and what open source you're using, and that you should have a means to an end of being able to understand how you actually build software, you're not going to be able to move that needle. You'll be playing whack-a-mole, right? I built the static analysis tool. I love static analysis for a certain type of thing. I've done pen testing. I like dynamic analysis. I like a lot of security techniques, but realize that those things are point solutions that are way far in later in your development cycle, and we still haven't sort of created a better hygienic development in the first place. You know, it's like I look at software, and even software that I've developed, and realize that, you know, at the end, release, and you're happy about the features, but you feel kind of dirty about how you got there. It's like, oh, well, it works, but yeah, it works. I remember I was doing a review for a company, and a security review, and we were asking them, you know, hey, can we get a copy of a control matrix so we could do authentication and authorization, right? And there wasn't a copy of the control matrix. We don't really not understand what's in our software, and we're really playing whack-a-mole at the end. And part of it is, you know, we really have, these are old numbers, right? I was talking to our CFO the other day, because I look at numbers all day long. I look at stats, and I was telling our CFO, I said, I dream of numbers. He said, I've got a job for you. I said, no, I don't need those numbers. But, you know, Central, for those of you that don't know, so Central is the place where Java components live. So as we move into the next era of software development, we're finding that we're finding places where we want to go and get our software some known place, right? So this Central was built to solve a different purpose. Back when Maven was first created, it was attempting to solve a problem with just building open source software. So Jason Van Ziel, who founded Maven, was trying to solve a problem that every time he wanted to use some new piece of open source software, he had to go find its website, go to its website, download its source code, go back to the website, look at its build instructions, get about a page into it and say, oh, you know, I'm just going to type, you know, ant make. Okay, that didn't really work, because back then it was like, oh, well, you need to get this other piece of software. So you'd have to go back to the website, go back, find out, download, and it was ad nauseum having to go back to build something. Like, I just wanted to use this library. I didn't really need to understand how it built. So he created this dependency resolution system, which is now what all modern package managers use. Right? Some sort of dependency resolution. So you want to use this library, but this library, in order to use this library, it depends on all these other things. You don't want to have to go figure out how those things come to be. You don't want to understand how they build. You just want them because you want to use this thing. So Maven resolves those dependencies. Well, in building that, it's like, well, we need a place for these dependencies to live so that when your build goes to request them, they can come from someplace. So that's where Maven Central came from. And if you look at its growth rate, it's exponential. You know, when we first started tracking in 2007, there was, you know, a few thousand components. Now we're up to around 600,000 different components in Maven repository. Now you look at NPM and the growth rate of NPM and Node, right? We see a similar trajectory, right? We're actually there. All these ecosystems are realizing, even Docker, right? Like, oh, we should have these repositories of packages so that when people want to use something, they can say, oh, here, where do I go get it? Well, I don't have to go figure out how to use this thing. I just want to type a command, and lo and behold, it comes. Well, that's when you think of it, that's almost like a thought that we've allowed this to go so far without thinking twice about, oh, wait a minute, where is this stuff really coming from, and what is it? And I'm still kind of scared because I know that people joke about when you use Maven that it downloads the internet, right? Well, we can laugh that it downloads the internet, but guess what? That's what's in your software. It didn't even just download the internet; it put it in your code, right? So the joke isn't download the internet. The joke is, hey, guess what? That's really what's in your software, and we kind of ignore the fact that the train is sort of already. Now, this isn't a bash on open source either, because I love open source. I think this movement has created a lot of things. We wouldn't have Hadoop, Tomcat, Jetty, Log4j. I mean, the packages and the innovation go on and on and on and on. So we can't. This isn't to say, oh well, open source is bad. It's not. It's essential. That's the key thing here, is that open source is essential. We weren't talking to one bank in overseas. When we do a bunch of different stuff, but we were giving a report saying, hey, guess what? Here's all the open source that you use, and here's some stuff that you might not want to use. And the CEO was like, when did we start using all this open source? Because they think of open source as MySQL, like, oh, we use Oracle, or Linux, well, we're a Microsoft shop. And they're like, well, when do we start using all this open source? Well, all right, we're just going to stop using it. The VP of engineering says, I just want to let you know that if you want to stop using open source, then I'm not going to be your VP of engineering anymore. Because we don't have a business if we're not using open source. Even in Java, right? I joke sometimes. They're like, "Oh, well, we don't use a lot of open source libraries." I says, "Well, do you use Java?" And they say, "Well, yeah, we use some Java. Java's open source." Just letting you know, little cat out of the bag. Java's open source. The interesting thing is when we first ran this survey, right? Heartbleed was, one of those moments where a large part of the world woke up to the fact that in this open source, and now I've got this problem. It was like, it was faster than when, I remember when Dan Kaminsky announced the DNS rebinding attacks, and he threw the map up. I think it was RSA, maybe it was Black Hat, threw up the map of how fast people patched. Like you could see it going over the world. Heartbleed was for the most part. Heartbleed has a very long tail because a lot of people don't even still they're really using OpenSSL and where they're using it, especially when you talk about embedded systems, manufacturing. Is it really, am I really vulnerable to this? There is still a long tail. I've been doing some research on mean time to repair, how long it takes organizations, in this case open source projects, to notice the fact that they're using something that has a vulnerability and then actually patch. And it's really, I'm getting some really interesting stats that on average it takes the average open source project, this is open source, to one, realize that they're using something that's vulnerable and then patch that. It takes on average 391 days for that one open source project to realize that its first level dependency has a vulnerability. Now, when you think of that, these dependency graphs get very large, very quickly. I've seen cases where it's years before it gets patched. And I've got some other slides in here that talk about some of my favorite types of components. Some of them haven't been updated at all, ever. Right? Even though it was an awareness, people were all actually saying, oh yes, this is something that I'm actually being vulnerable to. I now realize that open source software can expose my organization. But do they really care? I could probably say this about security in general, right? It's at a security conference. So oftentimes at a security conference, we all care, otherwise we wouldn't be here. But for the most part, we really don't. Right? Don't tell anybody, but we really don't care, right? Because they say, oh yeah, even though, right, we know we're being exploited, we've had incidents, right? Do we actually have a policy? Oh, well, maybe. Well, if we have a policy, do we ever say that you can't use these particular components? Well, no. So to me, these things don't match, right? We think it's important. We know that it introduces of exposure, but yet we don't have the ability to say there are things that we just shouldn't use as an organization. Just shouldn't use. I remember when I was doing static analysis in C and C++, I used to say, get S, don't use it. People were like, oh, well, you know, and then no. It's like one of those things, you just don't use it. There's no good reason to use that library. Well, we have the same thing, right? No longer is it a single method call. There are libraries, we're like, don't. One of my examples in here, I get, hey, this library is 10 years old. And it hasn't been updated in 10 years. Do you think it? I don't care how great you think it is. Right? Do you think there might be a better choice for you? Our own technical software that we write. But the software that we write depends on other software. What about that debt? It has its own debt calendar that we just completely ignore. So when we're like, oh yeah, we care. Well, no, we really don't care, because until you can really understand what's in your software, I recommend everybody that can just take a look. You know, even look at some of these components. Look at the release history. I bet you there's some stuff in there. You know, you'd be like, sure. And then developer says, well, yeah, it works. We need this. Like, do you understand what it does? Maybe. Right? To me, the proof is in the pudding, right? We say we have a policy, right? But oftentimes the policy doesn't even cover security. Because when we think of open source, a lot of people, the open source policy, the whole notion of having a policy on open source is started in worrying about legal concerns. We're concerned about IP risk. We're concerned about GPL licensing in our commercial software. So when you think of open source policy or open source, it started as a legal movement concerned about legal risk, and it's about licensing. So oftentimes, like, oh yes, we have a policy. The question is, well, does the policy concern security? 9 times out of 10, it's not even in the radar screen, because we're so focused on, do we have any GPL in our code? That's not the only problem with open source software. Not to say that you can't have it the other way, because the other problem is that it's not just a security, it's a quality problem too. If I think about it long and hard enough, and I'll probably beat this like a dead horse, it's a problem of not knowing what in the first place. And not knowing brings a level of risk, because there are better choices that you can actually make. Right? When we look at this, only 21% prove that they are not using components with known vulnerabilities. This is not something that's hard. You can know what components you're using. You can know what vulnerabilities that they have. That does not mean that you've satisfied, are there any other additional unknown vulnerabilities? This is not a question of, well, the known unknowns, right? But there is a set of data that says, hey, this is a thing that you're using. It's 9 years old. It's got a really bad vulnerability. You might not want to use it. Do you have a policy that says you shouldn't use that? I mean, it seems to me very basic. Even if you're a consumer of software, I've got software, I'm buying software. Wouldn't that be a really good question? Hey, IBM, WebSphere, does WebSphere ship with any known components that have, because, yeah. Well, we know the answer to that, but the reason why it does is because nobody's asking. Ask, you won't know the answer, which goes back to, shh, don't tell. We really don't care. Right? What about the developers? right? We know on average, even just Maven Central, a component is updated 4 or 5 times a year to fix known security issues or quality issues. Does anyone actually monitor this? I mean, it's very rare. I've been doing some graphs and some analysis of, there are certain types of developers, certain types of organizations. One, which sort of are fast movers. New version comes out, we're updating. Right? Then there are the ones that are like, yeah, I gotta like worry about all this other stuff. So lo and behold, fast forward a few years and you look at what you got and it's pretty crufty and crunchy. Because we're not paying attention, right? It's so easy to type, hey, I'm going to add this dependency in my POM file, and then you do it once and you forget it. Until, oh, well, really never, right? Unless there's some new specific feature of that library that you're using for, then you might update. But that's the problem, right? That's the problem that we have, is that we really don't pay attention to this. We don't certainly look at vulnerability data. I talk to the average developer like, oh, you actually look at CVEs? I know we got that. I can't wait for the day that I no longer have a job as a security guy. Because security to me is a discipline that we should be working really hard to make it not our job. I think in some cases we spend a lot of time making it, hey, I'm the security guy, I have all the security knowledge, and I'm going to keep that, right? Because that's what makes me special. The reality is that we don't scale. Look at this room. There's not enough of us. I don't know how many rooms across the country. You go to an average dev conference, you go to a room where they're talking about the latest DevOps Agile thing, hundreds. They're like rats, rabbits that just come out of the woodwork. Right? You go to the hall, which is the security geek hall, and there's 50, 25. Right? We've got this problem that we have to make sure that it's not our problem. It's a developer issue. We've got to make stronger development, realize that this is something that you can't be saying, no, that I don't care about this, I don't know about it, it's not my problem. We have to completely flip this kind of stat. Or otherwise we will continue to fail fundamentally as a security industry. Because we don't scale. We never have, we never will. I mean, I used to joke, some organizations say, oh, we used to, that security training is important. And I think security training is extremely important, right? But it should be just developer training, not security training. We're not trying to make security folks, trying to make developers that can understand their responsibility from a security perspective. Because if you train them to become security experts in our current industry, it won't be long before they're not your developers anymore. And a lot of these are really tongue-in-cheek, right? Well, at least we know that it's all good in production. Production is not a problem, right? Does your organization maintain an inventory of open source components used in production applications? Some organizations, many of us, it may be lucky to even understand what applications you have in production, let alone what's in those applications in production. Right? When we talk about this, the industry, we like to think of this as a supply chain problem. Software is a supply chain. We need to apply supply chain mechanics. This is not something new, nor is it rocket science, but we're not even taking the basic steps. We don't know where our stuff is, and we don't know what's in it. So when there's a problem, we don't know if one, we have the problem, B, where in all the places is that problem, and C, how can we actually fix the problem? Because we don't even know what we have in the first place. We struggle with, hey, this new CVE, Hartley comes, hey, the CEO, somebody says, well, does this impact us? Someone, oh yeah, we don't have any of that, right? Then you go farther down the train, eventually you end up at some developers like, oh yeah, we got that all over the place. Because somebody knows, but it doesn't transgress across the entire organization, right? A bill of materials, incomplete, right? We don't have bill of materials. Bill of materials, fundamental thing. We need to start thinking about this. Our software bill of materials, what's in it? What do we have? What do we have? Build something? What do we have when we're building it? What do we have in production? What do we have? I think this is it. This is the, as I sort of belabored that point a little bit earlier, right, is that we all point fingers. It's somebody else's responsibility. To me, when I look at this chart, it's because nobody really knows where the responsibility lies, right? Application development, I'm actually surprised by this, right? That 40% says application development owns this. Because I think if you were to talk to application development, they would say it's 40% is someplace else. Right, so I think this is somewhat biased by the title of the person that answered this question. That as you get more developers, oh yeah, no, this security guy, right? Oh yeah, I mean, even our developers, right? I work at a development organization. Well, like, hey, we've got this thing. Is it important? Hey, what's the proper way to fix this? And I will often be more coaching, be like, okay, well, here's some things that you could try. Here's some resources that you could go look at. Because I want them to own the responsibility that I'm not here to tell you how to fix something. You have to take on that responsibility to understand the ramifications of the decisions that you're making and the actions that you should be taking as a development organization. Not saying that this is a security thing and we got a security guy to do it. Because there's not enough security guys. So we think we've got policies. Are they doing anything, right? I love this. We don't need no stinking policy. What would I need that for? I mean, come on. I think part of that is because the way in which we think of policies. Right? Policies are things that are a bad word, or it's a spreadsheet, or it's a guide, or it's a thing that slows down our process. And policies shouldn't be that way, as something that, hey, we don't need one because we think it's a burden. We need to sort of switch it on and say we need one because it's a responsibility that we must bear as an organization that wants to strive doing better and building more quality software. And then I love this one, right? We have a policy, bacon. It's because we have a policy, but it's not really doing anything, right? You don't have a policy if you don't have any way of controlling it. Hey, yes, I mentioned the policy early on the deck. It says, oh, well, we don't really address security. So some people are like, oh, yes, we've got the policy, right? It's in the employee handbook that you sign, right? That we've all read our employee handbook. We know exactly what the policy is. As a CSO, I've had to read the policy that we have. And it's like, oh, yes, you cannot drive and use a cell phone. That's in the policy. That's in the policy. Why is it in the policy? It's to protect the organization such that if I ever was driving with my cell phone and was in a crash, they could say, hey, guess what? In the policy. Sorry, your fault. Policy is no good if it's just written down and nobody understands it, knows it, or follows it. We don't care. The problem is that it really is our applications, right? Hey, if it works, ship it, right? The reason I mentioned this is that components are like crack cocaine. It's like crack cocaine because we choose components for one reason. For its features and capabilities. That's why we choose something. First thing, oh, what does it do? Oh, it's log back. Oh, it's got all these great log features. Oh, I want that. Right? Oh, right, it's this newfangled library. All my friends are using it. Everyone's using it at Stack Overflow. And these guys at Facebook or these guys at Google. And I heard this thing and I saw this talk. And it's like the greatest thing. And I want to be the next greatest guy to use the next greatest thing so I can be famous of the first guy to use the next famous thing because it's cool. I joke about this all the time. I think of it like music and my daughter. Right? It's like, oh, hey, guess what? I just saw this band, and I think they're really good. And the minute I think it's good, it's no longer cool. Right? That band has sold out. Software components the same way. Oh, these struts. Oh, yeah, they want VMware. I sold out. This other thing got really popular. We need another DSL. Do we? Do we really? I mean, how many DSLs are there? I was like, oh, okay, JavaScript. Like, JavaScript's not bad enough. We need CoffeeScript. well, HTML, we need Jade, and well, Jade, we need Mustache, and I was joking with a guy back there. I said, I woke up, I feel like I woke up and I was in a coma, and all of a sudden there's like all this stuff. And I thought I knew a lot of stuff about a lot of different software languages, and then all of a sudden, like, oh my God, everybody's using something else, something like, oh, I want to be the mustache template guy. I mean, to me, I don't even get CoffeeScript. I mean, okay, I get it kind of, but guess what? You have to like compile it to JavaScript. So you write something so you can compile it to something else, so that it's in the browser in JavaScript, so you can actually like see what it is and debug it. So why bother? Do we really need that? Now, you guys aren't probably developers, but maybe we should have this conversation over beer or something, because I don't know. So what application training is available? Security thing is such a drag. Get me to the bacon. Oh yeah, we got some e-learning stuff, and we do these things, and we should be doing more, and bacon. Clean up on aisle 9, right? We do so much, but not enough at scale, right? Licensing is another issue. I've got a few more minutes, but I've got to get to these. I say if you're going to look at something, look at things like these. I say this tongue-in-cheek, right? Because this is not about opponents being an apocalypse. It's not going to kill you. But you should at least have an understanding that you've got one of every single one of these in your application. First one is what I call the virus. Virus happens to be something that is used by everyone. I say this because another interesting thing is that look at these release dates, right? This CVE 2011, number of dependent components. What this means is that this particular has close to 9,000 other things which use it, which begins to spread. Right? It's downloaded 7 million times and being used by 72,000 organizations with a CVSS score of 6.8. And I like that last line, right? Instance to execute arbitrary commands in the Lang runtime class. Not a problem. And the mean time to repair, 229 days. What that 229 days tells you is that of these 8,781 other projects which use this thing, on average, them 229 days. So I say this is the virus because when I look at the mean time to repair, this is only one dependency deep. Each one also have other dependencies, which have other dependencies, which have other dependencies, which may be the thing that you're actually using. Life of the party, the guy who's got all the friends. This one I like because look at 2009. Right? Remote attack service, malformed XML input. The interesting thing about these XML ones, right, is that, and I've noticed this, older CVE in such a way that nobody really pays attention to them and updates them based on latest attacks. Struts, right? I've seen struts which were a 4.8 CVE. People are like, I can't even get out of bed unless it's a 7. Sorry, but 4.8. But because of the way that the OGNL works and the way that researchers took a look at that and looked at later vulnerabilities, that 4.8 should be a 10 because you get remote code execution. But it was published years ago, and once it's published, it's right. There's really nobody that's paying attention to these things and saying, oh, let me go look at these old ones and see whether a new technique could really be leveraged in a different way. I mean, if I was a researcher and I wanted to like shortcut some of my work, a lot of these ones are pretty juicy, especially the fact that it's 120,000 different organizations being downloaded 4 million times. Might be a problem here. Those 119,000. The forgotten. Let's not forget about the forgotten, right? 2003. This is like the oldest CVE. And this, let me read this thing, right? Processor version class and Java plugin 1.2 assigned applets. Who still uses that? Hundreds, right? Number dependent, there are 75 other components which still rely on this. The CVS score, I mean, you look at these, hey, guess what? These things are there and they're being used. I look at, you know, I joke, but I look at these all the time. I'm still amazed, right? The undesirable, right? This one is a curious one because the undesirable is a component which has no license. You can't see it. It's not observable. It's not declared. It's just no license. You know what no license really means? No license means no rights. Because it's the license that gives you rights to use something, right? So this is saying that, oh, well, not only the last release date was in 2006, we're still seeing it downloaded and being a dependent on a lot of other different components. But hey, why should I care about these things? The unproven, eh? We don't really know what it is. It's the I am what I say I am. These are components which have I want to say my license is one thing, but there's no way to verify that that license is actually correct. Right? When we look at components, we like to do a two-test verification. One is the component says it has a declared license, and two, you can actually observe what that license is. Meaning you can look at the source code. Guess what? Source code is not available for this. So you can look at the source code and verify that the license in the source code matches what they said it was. Because nobody would ever say that it's one thing and have it not be that thing, right? Well, your guess is as good as mine. One hit wonder. Love iced tea. Right? One release ever. It's only ever had one release. I mean, really. Do you really think that this is like a good thing to be using? Should I have components in my ecosystem that its last release was in 2005 and it's only had one and never had a... I mean, does anybody even understand what this thing does? Oh, it says it's a regular expression parsing library. Relatively popular, but it's ever. And the last was 11 years, well, no, 9 years ago. My math is up. Things that each one of these 7, every single one in your software, every single one. Simply, you can organize the way I build software such that these are very basic things that I can at least prevent. Hey, or I can at least ask, why are we still using this? What happens if there is an issue? Maybe if we really think that this is really important, maybe you should it's got a security. Nobody else is. Right, we like to talk about open source as the many eyes theory. Well, there aren't a lot of eyes looking. And if they are, they're certainly not telling. Of course, I've got like a minute left. What matters? Part of our survey asked what people like to eat on their pizza. And they were really upset that bacon, I realized that, and that's why I added bacon to some of my titles, because I realized that bacon is like, it's just like one of those things. The smell of bacon. I can actually set a clock. My wife and I like put some bacon on the pan. We could just set a clock and like feigning, like he's like, oh, I barely cracked open. He's like, what are you cooking? I'm like, you know what we're cooking. Otherwise, you wouldn't down the stairs. I guarantee that. And the other thing is that we prefer beer over wine. I think there's the brew thing. I think we did the brew thing last night. I think there's a pub crawl, might be more beer tonight. I think that validates the fact that but beer and soda is going hand in hand. I mean, I used to joke when I was younger that that we would always be the hacker's the guy that's got a full of cigarettes and a bottle of Surge soda, right? Because we know that Mountain Dew really didn't do it. We had to go for that little extra. But yeah, to me, I think the interesting thing to sort of sum up, and I actually finished on time, which is always a miracle, is that I'm glad that A9 came out. I'm glad that people are beginning to pay attention. I am still hoping for people to really start Because don't start looking at this, think about this as the delivery cycle. I have an entire different deck where I often talk about build as your build is a picture of the Willy Wonka's everlasting gobstopper machine. And it is like all these dials and whistles and horns go off, and you ask someone like, oh, well, how did, it's like, it's amazing how anything ever comes out, the software at the end, because you look at your build and it's a complete and utter mess. We can't know what's in our software until we begin to bring things moving left. And moving left is not just about moving our security practices. It's also about moving our hygiene left of how we build and understand what's in our software. And with that, I'm open for questions or beer time. Yes?
I was wondering, is something like Sonatype available to projects to actually use to analyze those things? These things are run by volunteers. They don't have tons of time.
So yes, we have made Sonatype available to open source projects. So if you have an open source project and you're looking for it, come talk to me. So this is not just a Java problem. I have the most insight in the Java ecosystem, but I'm also right now in the midst of doing work for NuGet Gallery and as well as NPM. So I run an NPM mirror, so I'm in the process of collecting that same set of data for those ecosystems. The problem is that there are different problems in other ecosystems. For instance, one of them is NPM just started components that are idempotent. And those of you that don't know what idempotent means, it means that when I say this version of this software, this blob 1.2, you can't go change it at some later point in time and say, oh no, wait a minute, I made a mistake. This is really 1.2. Right? Well, until that wasn't NPM, meaning that you could have two different versions of software, different bits, be the same version. Bad idea. Right? That's not a good repo. We're in the midst of working with Microsoft, and NuGet is a little bit wild, wild west too, right? Because you could sort of throw up anything. I mean, it's sort of like, okay, I looked at this just the other day, and I was looking at jQuery. So some guy, right, decided that he wanted to have a new package of jQuery. So that guy got jQuery 1.7 or whatever it was, and put it on NuGet. But the bits are different. So if you go to the jQuery site, download 1.7, both the minified version and the regular version, they're different bits. It just happens that when you look at it, you're like, oh, okay, what really happened is that he compiled it with a different flag. But the reality is that, I mean, I look at some of the minified stuff and I'm like, okay, I hope, right? We all kind of do this. It's kind of like, it really kind of makes me feel uncomfortable. Right? Okay, here's the regular version, here's the minified version. And you're like, okay, well, I'm gonna develop with this one, and I'm gonna hope and pray that this is the same thing. Because you look at it as one big line, variables A is, yeah, it's gotta be the same thing. That sort of fundamentally kind of makes me uneasy. Random repositories of some any old guy that can say, hey, this is this thing because I wanted to use, in Mac OS we've got Chocolatey, right? Like, oh, I want to be the guy that's going to create the Chocolatey package for this thing and call it this version, and well, is it really that version? Don't really know. So we are working on helping repos talk about how do we build better and manage better repos, but that still is a ways off because it's moving at lightning speed. Other questions? Comments? I appreciate sticking in. It's been a really long day, but I think there might be one more session left. If not, I think there's a beer crawl. I will likely be on it, and if you see me, I will buy you a beer.